Hey guys, welcome back to Rocket Gyan, my fellow space tubers. I guess you are all fine and doing great in your life. Today we are again back with this rocket launch which was supposed to happen yesterday, but due to some technical glitch in the guidance and navigation system, we had a hot fire abort. If you don't know what is hot fire abort, that simply means that the engine ignition happened for just few seconds and then it shut down. Maybe it didn't even come to full throttle. So, yes, that was a long wait yesterday in which we just waited and waited, and then finally, at the time of liftoff, we heard the hot fire abort. The best thing is that the rocket was safe, everything is good, and they were able to turn around and quickly resolve that issue, and now we are able to see the launch today again. So this totally screams that this rocket is robust in nature. So, hi everyone. Hi Rajesh. Hi Angel. Hi Brendan. Hi J. Jule Kelvin. Hi Tommy. And hi S. Kumar Hindan. So, um, without any further ado, let's just see what this rocket is all about. We have seen this rocket, but let's have a quick recap also. Uh, Hi, Bryce Gaming. Okay, so this rocket is a two-stage rocket, and yes, this looks like a Starship hardware in the first stage. And indeed, it is a Starship hardware kind of, you can say, because the body is made from stainless steel for the first stage, and then the second stage is hidden in this fairing. In this, you can say that in this interstage, and then the fairing. So this is an extremely small sat launcher, I would say. It comes in the electron rocket category, but again, the payload capacity right now for this rocket is around just 25 kilograms or so in polar orbit, synchronous polar orbit. So that is that, and otherwise, we can have a look at the rocket also. Hi, Crypto Walker from the West Virginia. Hello, everyone. So there you go. There we have the rocket. You can see now. It should be visible. So I guess so this is, you can kind of see how this looks like, right? Now, there we can see how the second stage will look like and the first stage. So let's see what is the first stage all about. So this is, you already know, as I said, this is a safe stainless steel rocket, and then it has this five engines in the the first stage. So these five engines are known as Delphine engines, and they produce a thrust of around 147 kilonewtons. Talking about the first stage fuel, it uses RP1 and LOX as its fuel, standard rocket grade fuel, and the cycle for the engine is the electric pump fed cycle, which actually makes a lot more sense for a small set launcher, because obviously, since it is a small set launcher, you don't want to have those complex plumbings. We don't even have a space for having those plumbings, as well as the space weight required. You don't even have that. So it's always to go with the simpler engine, which is always electric pump fed engine, because all the gimbal activity, the what should I say, the thrust level, the throttle level, and whatever normal things which are controlled mechanically by plumbings in normal rocket engines are basically controlled by software in electric pump fed engines, because you can literally control a software for a turbine to rotate at a certain speed so that a throttle can be controlled, like that. And talking about the second stage, so this second stage is, you can say, literally a skeleton material out there. It has two tanks, one oxidizer and one RP1. This is also runs on RP1 and LOX, and you can see the engine. Actually, here the engine is quite simple. The reason being, this engine is basically the pressure fed engine basically. So there is no complex cycle going on here, just the pressure and the igniter, both of them igniting them and giving the thrust. This produces around 3.1 kilonewtons of thrust, And yes, you can see now it can take on 25 kilograms of payload. Although for 25 kilograms payload, this fairing looks quite a long and large, but it has to house first of all the second stage, as well as the payload capacity is tend to increase to 100 to 150 kilograms also in uh, other iterations. So that is the rocket we have in. You can see that in front of you. Okay. Uh, just a sec. Let what. Do you have anything else you can ask me right now? And talking about, okay, let's have a look at the. We didn't look the launch profile, right? So at that, what payload it is carrying and what inclination it is going. So the payload, first of all, the launch site. This is also a new launch site, a Kodiak, Alaska island, and it is situated in mountains. So they naturally get a boost in ISP from their engines. Also, it is going to a 70 degrees inclination, 415 kilometers orbit, which is kind of a polar orbit, but not exactly polar orbit. And altitude is also kind of, you can say, quite high. And this mission will include a non-deployable Space Force payload. So there was a DARPA contest in which this Astra rocket company only survived, and they had a contract to demonstrate two successful launches with the US Space Force payload. Right now, they are saying it as a Mars simulator, but we all know it won't be a Mars simulator. But one thing is that it is not. It is a non-deployable payload. So. Um, like in a week or so, it's like going to 415 kilometers orbit. So kind of you can say in a week or so, in a week or in months, in few months it will naturally decay and come down. So that time the Space Force payload can do its operation. So that is that. And talking about the mission timeline, you can see that it's just begins to pitch over at around t plus 12 seconds, and at t plus 8 minute 30 seconds the final deployment basically happens. So it's a short flight to space, not a very good very long weight to space. Basically it has a high thrust to weight ratio, so we have to watch out for that. The second stage is the first stage is Delphine, the second stage is Ether engine, ether, whatever you want to say. Thrust produced is for 32,500, or you can say 147 kilonewtons, and the overall length is 43 feet. So yep, that is that. That should summarize the mission and everything. Can you tell us about the fault yesterday if possible? Yes, right now they haven't let us actually declared in public what actually happened with the fault or with the launch, so we don't know. uh, yeah, so we don't actually know the exact reason, but as they say in the last stream only, that we they had a problem with the uh, what should I say, the guidance control system. But the Scott Manley himself said if there was a problem with the guidance system, they should have been means the computer should have pointed it out way before the ignition. We don't know what actually happened there. Maybe they have something going on with the flight sequence which checked the guidance system at that point of time during the ignition. So yes, um, right now we only have that information. So okay, so there is a delay, which is not good. So let me just confirm what actually. Let us see. No, it's okay. I guess there was. Okay, so that new T0 before the. Okay, so we do have a new T0 now. Uh, right now, before this, we had 2 p.m. Pacific time liftoff, and now it has slipped to 2:45 p.m. Pacific time liftoff. So that's that, and we'll have to wait for. Okay, we do have some time. Okay, we can explore this rocket a bit more if you want, or anything else you want, because we have this thing going on, and whatever you want to see or have, we can do that because will be having some. Are having like 45 minutes or so. Yep. Let's just see this rocket only. So this is we have exploded right here. Okay, so let's just see the what will happen when it launches. Okay, so how the things will look like when it launches. So let's just quickly load this thing here. Thing come take some time. There you go. Finally, we have the things here. And we can move. Basically, if you see that this actually is okay, I won't say. What do you think this where is this launch site situated? Can you tell me, guys? From the looks of it, I mean, obviously it is not the Kodiak Island, but still this you know, whatever you are right now seeing, where is this launch site situated? This is the flame trench going on here. We can even go inside the flame trench, see what is, wow, what is like to be inside a flame trench when the rocket lifts off, right? Let's have our rocket here now. uh there you go. Still, it is actually kind of hanging in air, but you should get the feeling of it. So yeah, let's just come move out from here and see how the launch sequence will look like, how it will look like when it launches. Okay, it is good. We can even see the launch from this tower. Okay, let me see. So there is what did you guys say? Cape Canaveral, Florida, LC39A. What? Okay, kind of. But don't you think it looks like more like Boca Chica Island, which means the SpaceX launch site? Don't you think like that? There was one way, but okay. We'll go from here. We'll try to go above this star and then see the launch. Or what do you suggest? Where should we see this launch from? Should we go to the top of the tower and then see the launch, or just near to it? We can adjust the camera angles, no problem with it. So this is how the rocket looks like basically. We can literally stand in here and start the rocket. That would be cool, right? This isn't Boca Chica, okay? Uh, okay, we will see, okay? We'll see. So this obviously this tower is kind of there in Florida, Cape Canaveral, but okay, we'll see. The thing is, from the satellite imagery there, uh, can we make out from that? Is the thing. Okay, let's just launch it. Let's just launch it. See what will happen. And and we have a lift off. Let's just see. Go inside the flames. Okay. We have a lift off, guys. Oh, whoa. What? Let's move on to the next camera. There you have it. We have a liftoff. This is how it would basically look like. Can you guys hear? You don't hear the game sound, right? Okay, now you should be hearing. So, where is the rocket from here? The drone will not be able to catch the rocket, right? Obviously. So, better to have our things going on from here only. The pitching maneuver is taking place, which we can see actually. And let's just hide it. And obviously, we can't catch it from the drone. I guess is going here somewhere, but we can't catch it from the drone. This is okay. From the looks of this, what do you think? This is Florida or Boca Chica or what? You can see the island now. So basically, this first of all, you will see this is the first stage booster right now taking. Okay, is it too loud? So right now the first stage booster is doing its job, and you can see it's kind of a long mission. I guess means the first stage booster kind of works hard to push it out of the atmosphere, which we can see because the basically the Miko happens at that point of time when it is like around 100 kilometers or so. There you go, the fairing sep, and we have. There you go. Okay, I didn't see. We have the ignition of the second stage. We have the separation, Miko, and the ignition of the second stage now. Does look like a cool game, right? If you want, guys, you can also tell me if you want to see any of the rocket launch. I could do that. If you want to see any other rocket launch, just type in the chat, and let's see if we can see that. Maybe we can even next we can see the Starship launch. Let's see how that would look like. It will go on, this thing will go on till t plus 8 minutes or so, so it would better we can switch over to the other thing if you want. Thanks, Anthony Smith. I appreciate that. Okay, let's switch over to another launcher, and you just type in the chat if you want to see a specific launch. We can see that. Okay, let's now move. And there you go. We are here. We'll have zoom now. Then move in from still in beta. So, what do you want to see? We have Alpha, Antares, Ariane 5, Atlas, S5, Black Arrow, Delta 4 Heavy. Okay, just I actually want to see how the Starship launch would look like. The Starship. Where is Starship? We have all the rockets. Starship SN5 and everything. Yeah, there you go. Starship rocket. Let's move on. Okay, first of all, let's just move it to the assembly building or hangar and see how the scale would look like. So let's. Whoa. Dude, say this. This is actually a monster in front of okay. This Astra rocket, I must say that. This looks so cool. Yes, I can I jump it? Whoa. Ah. I guess I can't. I just pass through it? I guess I did. There are all the heat shield and you can see the scale only from the people standing in here, right? This is actually a monstrous rocket which we all know also, but this perspective, gets us going. The grid fins, what are these? Okay. Kind of like looks cool when we have it like this in the hangar, right? Try to make another approach. Ooh, oh. No, I'm passing through it. Indeed, people look too tiny. So now have we can move it towards the launch. Let's see. Starship launch would look like. There you go. Whoa. And there you have it on the launch pad. Whoa, man. This is indeed huge. Wow. This is indeed huge. I mean, we can't even imagine. I can't even imagine. Making such a huge structure, and now Elon is actually making a rocket out of it. Controlled explosion. Yeah, these are all the Raptor engines here. I am stuck inside the Raptor. Okay. But see the scale, dude. See the scale. Even it's even surpassing that tower. Wow. Yes, you can actually go and download it from the team. This is Rocket Explorer from Casper. I don't remember his name, but he had done this development on. You can see the founder also, who has supported him. Producers Tim Dodd, Felix, TJ Cooney, all are the big YouTubers have supported him. And yes, this is the although it is in early access form, so there are quite a lot of bugs in it, but yes, it is good. Okay, now let's move to the top of the tower and how will it look. I am now top of the tower and I can just see the booster with the grid fins. Wow. Not even the starship. Very good. See this. This is indeed huge. Now let's just launch it and see how things will. You are in what should I say? Proper time because okay. Get ready, guys. Let's see how the starship would look like during the launch. I'm excited. So, and we have countdown starting. Whoa! See this thing go, man! This is huge. Oh man, this thing is truly huge. This is just basically this is what should I say? Not the game actually, but the explorer kind of a thing. You can see here the Rocket Explorer on Steam. You can go and get it. Still in early version, so there are quite a lot of bugs in it. But yes, kind of cool when it comes to visualizing the rocket. Rocket, but again, it's the space. Wow. Should see. I'm pretty. I'm actually looking forward to what does it have in store for reusability. Then will we see the flying back to the launch site or what? Exactly. The amount of thrust, it is like million, I guess 2 million pounds or 2 million kilonewtons. I don't remember exactly, but yes, the amount of thrust is insane on this thing. This is a fully reusable holy grail of rockets, as Elon says himself. So it is kind of very cool. Now you should the stage. Okay, I guess it should be happening now. Have to wait and see. There you go. Stage separation. Okay, it just went away. Just went away. Fine. No worries. I can't switch over to that. Cool. So we don't have a proper. See, again, it's in development state, so we can't ask for much. So yes, that again, I can't rotate this thing also image. This is as it is. Can see the thing out there, the earth. We can see the launch site. Okay, so the launch site is indeed Florida. We can see now that island kind of a thing. So yep. Now tell me guys, what is the next one? What is the next rocket you want to see? Or if you want to do anything else, you can suggest me, because we still have some time before the stream goes live. Because it there was some I don't know what happened, but we do have the launch was supposed to happen at 2 Pacific time. Now it is on 2:45. We still have some time going on. Atlas, we can very well go with that. You can even tell me any historical rocket you want to see, or anything, any rocket that is going on. We'll see if that rocket is there on this platform. But historical rockets are also there. No, this does not right now has that functionality. I can just this is basically just for exploration purposes, how the things would look like. Okay, so we cannot interact with the particles or the objects. It will be like that only. But yeah, we can just see how the things will look like. It's literally a rocket explorer. It's not meant to be KSP. But he has done a great job in getting all those vibrations. You can see the engines being all those vibrations and everything. Okay, let me see if we do have any other update also in the meantime. Okay, so we have yesterday. Okay, so there is one more thing. Yesterday, SpaceX was supposed to launch their rocket, the Falcon 9, to the International Space Station, carrying the cargo Dragon to space. But now it didn't happen basically, and the reason being the weather. So that was a problem there. Now we will have to wait and see how the things will look like for today, because they had the again the next launch opportunity today only. So again they will be trying for their launch today. uh we don't have any as such update. So that's only the thing with that 1:45 Pacific launch time has been shifted to 2:45. So that is only we have. Sorry, two. I had 2 Pacific time has been shifted to 2:45. Okay, now we can explore any other rocket if you want. Again, I am not going into playing KSP right now. I could very well do that, but the thing is, why am I not doing it? Because right now my system is having some problems, I guess, and if I will load KSP now, it will take a lot of time, and hence in the meantime the actual stream will start. So no, nothing. We can't make them crash also. So we can go with the Saturn 5 or cool. We can go with the Saturn 5 again now. I guess this is pretty much about it. This has a very long burn. I don't think so it will have such a long burn, but yeah, that's what we have right now. Can move on to the next launch. There you go. We were stand. So let's have another rocket. I guess. Okay, Saturn 5. Saturn 5 or Saturn 1? That's Saturn 5 rocket. A Ooh, okay. This is also a humongous rocket, which is supposed to be, because it is again going to the moon. So everything is there. So let's go down and see. Wow. See those humongous F1 engines. Wow. We okay. You can see all the designs and everything. This is kind of a huge rocket. Okay, we'll see the launch from here only this time. Okay, and see how the things will look like. Wow, cool. I'll just go a bit back so that it is in the frame. Then we'll see the launch. Yes, now it is ready. So let's see. I guess it won't lift off from the pad. Yes, there's a glitch. There's a glitch here. Yeah, I actually still in the early version now, so I have to go to the change the scene and then again come back. So then only I'll be able to do something. Otherwise, there's a sticky launch pad bug there. Go here, load it real quick again. Okay, 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 okay. No, no. See, we still has some bugs out there. So don't expect much, but again, this is a cool app for visualization. So now let's just launch it. And we have a liftoff. This is actually simulated like that only. Wow. This looks so cool, dude. We can see the pitch over maneuver, but the plumes actually look realistic now. We can see the roll here. Wow. I'm very interesting, excited to see actually how the that Apollo module, rendezvous and change, basically flipping and again talking, how that would be simulated here. Let's see. Right now everything is good. John says Lego have a very good model of Saturn 5. I have one. It took over 6 hours for me to build. I guess yes, Lego, does create those beautiful models and everything. So I'm kind of jealous because I don't have any. And I guess we don't actually get those Lego suppliers here in my country also. If I want one, I don't think so I can just get one. I'll have to see and uh, wait and see. There, here in my country, we actually don't have much of those rocket models and everything. So uh, the space enthusiasts like me have to just to play with those paper rocket models and yeah. We don't have much actual models right now. ISRO again has uh, what should I say, initiated that official merchandise kind of a thing. We are kind of seeing some rocket models, but that is only from ISRO. Now I guess we should be seeing the stage separation soon. I don't think so. It will go to the moon, but okay. Let's see. Increase the time. Oh, there is the frequent. Whoa! This look great. Right now, those three F1 engines, four J2 engines. So let's increase the time. I would have loved to see if they have provided some camera moving capability. It is fixed right now. Second stage should be depleting of its fuel now. Anytime. Yeah, four times the speed right now. It's still burning. Cool. It has to do that because again it is going to the moon. It is not going to the low Earth orbit. You should consider getting a simple wholesaler reseller license and as well take advantage. I see there are some models out there, but again those are not super effective. Okay, so that happened real quick. We didn't see the stage separation properly. There are some suppliers of the models, but their models are not accurate as well as they look pathetic. Those are local vendors, so you can't expect much from them. But again, yeah, those are the things which we can get from in here right now. But again, the things could change with the ISRO officiating some merchandising and models and all those things again. But that would be that I have seen some models and they are great, but they are made up of metal and brass and they are too costly. Like you can say $100 or 70 to $100 for a model or just a PSLV model. 1969 pieces, the year of the moon landing. uh okay, that is pretty good touch if they had exactly 1969 pieces. That is so cool, man. If they have exactly 1969 pieces. Could see the stage separation. We have, okay, I guess have to wait. There's some ghosting period also here. I don't think so this is going to the moon though. Wow, this was great. Will it separate now or is it stuck here? Yes, it is stuck here. Yep, it is stuck here. It won't go much, I guess. Is what we have now. We didn't even see the launch escape tower separation. So the launch sequence is kind of messed up here. The flight sequence basically. So yep, the launch tower is still attached and don't see the Apollo module also, right? Not wrong. Yeah. So that was a bummer. Exactly 1969 pieces. I am actually wondering how would they have pulled it out. I mean, obviously you can have more or less than those pieces. How would they have designed it? Wow, cool. And one rocket is also there. LS shut. Every rocket is kind of there. Let's see. Look. Oh, whoa. The other rocket is so huge. This is the moon rocket, and again, the Starship is huge because it is reusable, not because it is designed to, you know, it's not a moon rocket basically. Starship is not exactly a moon rocket. It has to do some orbital refueling and everything. Classic N1. You can see here with the grid fins below. I don't. Wow. Okay. Were there some grid fins kind of a thing at the bottom of the structure? I don't remember basic exactly. But if it is here, I guess it was planned only. But why? Still, the Russians make their rocket like literally like a dart kind of a thing, wherein it is you can actually say it is very well stabilized during its flight in air basically because of its shape. It is totally, it's like a cone, totally a cone. And Soyuz is also like that. And if you have played KSP, you know that Soyuz is kind of extremely stable rocket because of its design. I guess it won't launch only, so I'll have to then change the scene and then come. One rocket. Oh, come. Okay, hit the launch button. This is indeed a huge rocket. Okay. Whoa! See those engines and the frame drop I'm having right now. There she goes. Trying to catch it, but I know I won't be able to catch this rocket, obviously. This is the max zoom I can have. Yes, it is right now performing the roll maneuver. And so let's now switch over to the onboard cameras. There you go. N1 rocket. Imagine N1 rocket launching from Cape Canaveral. It did happen right now. You just saw. Okay, hot fire. And you'd see the stage separation. There you go. Stage has been separated. Now it will propel itself. Would be a cool view to see from here. This hot fire ignition here. Let's see what that would look like. There you go. We are having a hot fire separation, and it just went. Wow, cool. And again, I guess the launch sequences are messy here, but yeah, we kind of get an idea of how it looks like. Imagine if the N1 rocket was successful, how the Russians would have transformed the space race. I guess if the N1 rocket was successful, na, we would have seen the people actually living on moon, having permanent bases there, but we didn't have those. Now we should be seeing the stage depletion. There you okay? Well, that was a bit okay. Okay. We actually don't have anything to look basically. Wow. But yeah, we have this, and I guess we won't be having ignition of this thing. Cool. So that was the N1 rocket. Okay, I guess let's see if we have a. Oh, it's the time. We'll have to wait a bit. Oh, again there is a delay, man. Again there is a delay of 45 minutes. Not 45 this time. 35 minutes. The stream will start at 35 minutes. Wow. What would we would do now? I guess have to open KSP, or I guess I can come after when it comes live, because I can see the pattern now and I don't know if it will come live again at that time. So what should I do? Chat suggest what I do. Basically, should I come live again, or should I continue this thing and maybe play with other launchers and see. Falcon Heavy, Falcon 9, the Falcon 1, a cute little rocket. Okay, thank you so much, John Wilson, for that $20. I'm so I can't thank you enough, guys. Thank you so much for all you do. Every little bit helps, so here's to help you building your own rocket. I guess I would do it someday, because oh, that is my, you can say, a thing right now. That is one goal which I have, that sending something to space, my own, sending my something, I which I have developed or something like that, to the space. And thank you so much for that $20, John. Really, really, really appreciate it. Why not just hang out and goof around? We can do that, but you need to suggest me what should I do, because maybe I can just open up KSP and do some KSP right there, but uh okay, let me just open KSP only then. or if we have any good or interesting rocket. Delta for heavy, the Delta for medium, the Black Arrow was this was made in United Kingdom, right? This was nicknamed as a lipstick rocket, if I'm not wrong. Yeah, this was named as lipstick rocket, which was kind of cool, you can say. Let's just go near it and see what it actually looks like and how many stages it has. A lipstick rocket. Whoa, okay. We have one, two, three, four, five, 6, 7, 8. But see the configuration of the engines. Oh no, I guess we have this is one engine only. We have four engines going on. I guess this is a pair, if I'm not wrong. I haven't read about it, so I don't know much about it. But yes, this is a black. What is it? Red Sparrow or Black Arrow? Black Arrow. So it was able to put a maximum 73 kilograms into a 200-kilometer orbit. Black Arrow is no longer in service now. Cool. The lipstick rocket. The three-stage rocket. The first stage being four engines, the second stage, and the third stage. Cool. What is this? Atlas 5. Let me just move it, the rockets properly. We know how the Atlas 5 looks like. So this is Atlas 5 without any boosters there. Cool. We do have this configuration of can have Starliner launch. Starliner is the normal Atlas 5541, the 551, 5531, 521, 511, 01, 431. Now the 4 series started. Although the what should I say, the nozzle for this looks kind of weird, the solid rocket booster nozzle, must say that kind of looks weird. And the Russian engine is here, the RD-180. Okay, let me just load up KSP now because otherwise we won't have anything. Or you are having fun having exploring this. What do you want? Should I load the KSP or is it good? The Atlas LV3B. Oh, this was also a cool rocket. The Ariane 5, which will carry the JWST, the James Webb Space Telescope, which has already completed all of its testing now, and it is being prepared to ship to the launch site. Wow, the world we are living in right now. The JWST is coming into operation soon, and let's hope this rocket, the Ariane 5 rocket, does its job properly and we don't. I can't even imagine if there is a failure for the JWST. Wow, what would happen? Such a long investment of time, energy, and money would go to waste. I just don't want that to happen at all. I don't know how the things actually, uh, basically how the policies are there in such a critical mission. Yes, you can play around with having the redundancy in the rockets and all, but how the policies would look like if there is a launch failure, then what would happen? That is a thing because for this Ariane 5 rocket, we don't even have a reignitable second stage if there is any concern regarding that. So, uh, in just one burn, it has to place it into a proper orbit, or even I guess it is not going into a orbit. It is just it is I'm not wrong, it will go to a translunar trajectory, translunar ejection, and then it will take the gravity assist from Moon and go into its intended orbit out of the Earth's escape, uh, Earth's zone, sphere of influence. But the actual thing, but I do know that it will take around a week in deep space to fully deploy the James Webb Space Telescope. It is so complex, and the stowing part of it is kind of, oh, mind blowing. It's not, it's actually, I would say, more difficult to store something rather than to make something, because you have all the resources you need to make something, but you have those particular dimensions which you have to play with to store something, basically, to make it inside a fairing. Wow. The entire is the Alpha rocket. This is also a new one, right? It. Oh, the Energia rocket. Okay, let's see this Energia rocket launch. First, what does it look like? This was where is the Buran? Okay, it does not have the Buran right now, but it was supposed to launch, I guess, the Buran shuttle, the Russian version of space shuttle, and see those huge rocket engines. Was it flew for one flight only, and then it was cancelled because it was too costly or so. I don't remember the exact history, but Russians did make some cool looking rocket, and yeah, this is one of them. How does it launch? But for that, out of this, come back, then launch. There you go. Let's see the launch now. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Whoa! And there's the roll maneuver, guys. And there it goes. It look dope, I must say that. Wow. And even it has some kind of, you can say, uh, what should I say? Symmetry, unsymmetrical booster, or is it just the roll which is causing that? This onboard camera looks so cool, man. It's definitely a badass rocket. Let's just up our time and see how this will look like during the stage separation. The booster should be depleted. This is a unique thing about Russia, that they, wow, you just saw the booster separation, that they basically use liquid fuel booster rather than solid fuel, because they believe, first of all, obviously the liquid fuel uh, is more efficient, but it is their manufacturing capacity and the tendency to make engines so cheap that they can afford to have them as a booster rather than have a solid rocket booster. It's kind of like comparable cost for both of them. So rather to go for the efficiency than just a bit more money. Hi Conquer Panda, this is Rocket Explorer on Steam. This is in early access, so there are some kind of bugs, but this is just for exploration purposes. You can't interact with them as such, but you just can see how the things would look like. There's it. Right now, the Energia rocket is flowing to the space. I guess now is the time the booster should deplete of its fuel. There you go. Oh, oh, whoa! That what was that, man? The rocket just went. Okay, okay, bug. There are quite a lot of bugs on in this, but it's okay. It's an early access. I can understand. Rock. This has electron. Okay. Whoa! Electron expanded fairing 1.2x. There are some versions of it. Wow. What else can we visualize? Things which we haven't seen. The okay, we can do this. I guess the GSLV Mark II, the H3A rocket. This is the launcher one for the Virgin orbit. But why is it standing on the pad? Okay, let's see the launch here of this rocket. It would be interesting because it is actually launched from there. But I guess he just let's see. Okay, we have something here. Just a sec. I guess we have the stream going on. What? Wait. Yep, we have the live stream finally. Just wait a sec, guys. Finally, we have a live stream. Let me just make sure everything is fine here.
Launch Vehicle 6, or LV0006, Astra's third orbital launch attempt. You're looking live at the rocket on the launch pad at Kodiak Island,
Just a
Alaska,
sec, guys.
and we're coming to you live again from Alameda, California, Astra's headquarters. My name is Thomas Burkhardt, News Director for NASA Spaceflight, and I'm joined once again by Carolina Grossman, Director of Product Management at Astra. Carolina, thanks for joining us again today.
Thanks for having me, Thomas.
So as usual, over the course of today's broadcast, we'll be taking your questions live. So if you have questions about what we're talking about, what you're seeing, please throw them in the chat. Tag us with @NASA Spaceflight. We're going to get through as many of those as we can over the course of the countdown and the launch. But before we get into questions, Carolina, can you give us an update on how we're looking for today's launch attempt?
Yes, of course. We are at T-minus 57 minutes and about 40 seconds from our liftoff time. The team has recently completed the go, no-go to complete propellant load, and as you can see, that frost line beginning to appear on the first stage, and the weather is looking beautiful in Kodiak, so fingers crossed for a smooth ride to orbit today.
Thanks, Carolina. We know we were a little delayed getting into today's webcast and into today's launch attempt. Can you tell us a little bit about why we had a hold earlier today?
Yes, so due to the abort that we had yesterday, around our T0 time, we made some operational adjustments, including a planned hold that just concluded about 15 minutes ago in order to
Just a sec, I guess.
condition the vehicle for flight, and we believe that this should address the issue that caused the abort yesterday.
If you were watching live with us yesterday, you know LV0006 got all the way down to engine ignition. You're seeing a replay on your screen now from yesterday. All 5 engines did light but shut down before liftoff. The data showed that those 5 first stage engines were ramping up to full power slower than normal, so as designed, the vehicle detected this and the launch was automatically aborted. After carefully reviewing the data, the Astra team has made some operational adjustments, and those should resolve the issue for today's launch attempt. Right now you're looking at the rocket on the pad, and as Carolina pointed out, you're seeing that frost line up top. As we talked a little bit about yesterday, that is the liquid oxygen tank on the first stage, getting nice and frosty from the cool liquid oxygen on the inside, condensing the air around the rocket. Below that is the kerosene tank, which is not super cold, so there's no frost line on the bottom part of the rocket's first stage. Astra, for those who may not have joined us yesterday or need a reminder, can you tell us just a little bit about what today's mission is all about?
Yes, the mission today is for the United States Space Force as part of the Space Test Program. We do have a test payload aboard our vehicle, and this means that it is Astra's first commercial launch. It is a test payload, so it will not be deployed, but we will send a signal that would simulate the deployment and test that capability.
Gotcha, and this is of course Astra's 3rd orbital launch attempt. 2 prior launches. Want to talk a little bit about how those launches led into today?
Yes, so every launch that we have conducted of our Astra vehicles, we intend to learn from and improve. Our last launch in December, we made it very, very close to reaching orbit. We were just half a kilometer-second short of reaching that orbital velocity, but it was a fantastic outcome from what we were hoping to achieve. And so with this vehicle, we've made adjustments, we've resolved that issue, and we've made a few other enhancements in order to improve our payload capacity on this flight. And with that, we're hoping for a great outcome with today's launch.
Can you talk a little bit about what those upgrades and changes were between Rocket 3.2 and the debut of Rocket 3.3 today?
Yes, so first of all, the issue that caused us to fall a little bit short of orbit was an issue with our mixture ratio control on the vehicle, and so we addressed that issue. And so we expect to deplete our propellants in the appropriate way so that we can make it to orbit today. We also stretched the first stage tank 5 feet to allow for additional propellant to provide more payload capability, and we consolidated several components on the upper stage of the vehicle to, again, provide more payload capability.
Gotcha. Thank you very much, Carolina. We'll keep the questions coming. If you have questions in chat, tag us at NASA Space Flight. We're going to start getting into those here. First question, talking about where are we launching from today? It's a beautiful launch site up there in Alaska. Can you tell us a little bit about Kodiak?
Yes, so you can see our launch site is in beautiful Kodiak, Alaska. That is 250 miles south of Anchorage and is actually the 2nd biggest island in the United States after the big island of Hawaii. And it is the home of the Pacific Spaceport Complex America, which is was opened in 1998 and has been the site of previous Astra launches. We really enjoy both the beautiful scenery there as well as working with the fantastic PSCA team, and we are very grateful to them for their support in continuing to operate safely and efficiently.
And I believe there are some advantages from taking these early test flights up there in Kodiak. It's not a very busy launch range. It's not one of the traditional Cape Canavers or anything like that. And it's also very remote. I believe that gives you some advantages on these early test flights.
Yes, absolutely. It's been great to be able to work with the team and get the opportunity to have such long launch windows. For example, our launch window for this mission extends through September 11th, which would be very difficult to achieve at a busier range. And so that's just one of the many reasons that we enjoy launching out of Kodiak.
So in addition to Kodiak, what is Astra looking for in potential future launch sites outside of Alaska?
Well, we're looking to get our customers where they need to go. So we are exploring launch sites within the US. We are on a mission to provide daily space delivery, and the location of our launch sites will really be determined by where our customers need to go. So from different spaceports, you have access to different locations in space. And so this launch site in Kodiak is particularly advantageous for polar orbits and high inclination orbits. But if our customers need to go to lower inclination orbits, then that would be more challenging to get to from a place like Kodiak.
Gotcha. Before we dive into some more questions, let's listen in to the pad mics and the teams on the countdown net as the countdown proceeds past T-minus 51 minutes and counting.
Yes, Wildflower, it is being launched from Kodiak, Alaska, the mountainous region, and near the pole. So it is you can kind of say that it's since it is near the pole, it is kind of beneficial to launch from there to get into the polar orbit. So yes, it is from Alaska. And talking about this launch site, we have one more company which has actually, taken what should I say, signed a contract with Indian space startup Bellatrix Aerospace, which will launch. Which basically, it has signed a contract in which this launch site of Alaska could be
And joining our
provided
live
to
coverage now is
Bellatrix
Benjamin Lyon.
Aerospace to launch their rocket to polar orbits also. It's kind of a cool thing which they have done.
What your responsibilities are here at Astra.
Sure. Well, really, I think it makes sense to talk about Astra's story so far. I think really Chris and Adam have done an amazing job to get Astra to a place where it has demonstrated orbital capability. And so my background is really about taking key technologies and taking them from prototypes to products. And so that's really my job at Astra, is to help Astra really get to that next step.
And how are you leveraging your prior experience to make that happen here at Astra as we're looking at one of the hopefully final test flights before moving into a more operational phase?
Sure, it's a good question. I think there are a couple of things. The first is, I think there's an incredible value to focus. This is one of the things I've learned in my career. And so really focusing down on executing our ability to get from to the rate we want to hit this year, as well as build this team that is already a set of incredible people out to a size of a team that can really execute.
Yeah, I've heard you talk a lot about, and when we're here at Astra, we see a lot of the teams that are building these kind of rockets and all of these systems. They come from a lot of different backgrounds, and there's some really unique perspectives coming in to make a truly different launch service. Can you tell a little bit about just how valuable that team really is?
Yes, when you want to create a complete product, it's really a whole set of things that come together. It's not just the hardware, it's not just the software, it's not just the services, it's not just the factory operation. It's all these things have to come together. And when you bring folks from a broad variety of experience, people from tech, people who are rocket scientists, people who have experience working with the various different kinds of customers that Astra has, that makes a real magic happen. And so building a team of folks that are really great also attracts other folks who are really great. So all of that put together makes just a really kind of magical elixir.
That is so cool, and it's definitely visible here at Astra. You see it all everywhere. What is your and your team's biggest engineering focus at Astra right now?
Well, we're really focused on execution. You saw Vehicle 6 is on the pad right now. We've got Vehicle 7 in flight, in production, and that is where we're completely focused, is making sure that we maintain the learning velocity and we learn everything we can from every time we go to the pad, and we apply that learning and iterate as quickly as we can.
Gotcha. And lastly, one last question before we let you go. Once we get a little further into this countdown and we're getting towards T0, where are you going to be watching from and what are you going to be doing at liftoff?
Well, I will be helping out the team as much as I can on comms outside of mission control. Usually I find myself in mission control for the last 15 or so minutes. But my job at the end of the day is to let these folks do the great work that they do.
Awesome. Benjamin, thank you so much for taking some time to join us, and good luck to you and the rest of the team on today's launch.
Thank you, Thomas. Appreciate it.
Let's go back to the pad and listen in for some activity on that countdown net as the countdown proceeds past 46 minutes and counting.
So guys, keep the questions coming and tell me if you want any, if you have spotted the, okay, there is something going on in the mission control, and the whatever you are seeing is actually not from my end, the buffering. So it is from the source only. Yes, we are going in with the live feed only. I am not dropping any frames on my end, so the problem is from the source. So there is a buffering which is coming from the source, but there is something in the mission control. If you can spot and tell me right now, there's something interesting in the mission control. Waiting for the answers right now. Can you spot it? I guess this feed is having a problem there, because whenever they switch over to this feed, now there is some kind of buffering which happens. This is not at my not the blue thing. Wildflower, try again. I mean, it's, what should I say? It's warmer to blue thing which you have just pointed out, but yeah. Yes, the tonk, the googly eyes. You can see on the back of the monitor of that person, there are those googly eyes. So you can kind of say that the Astra people have their personality going on their computers also. So yeah, that is one interesting highlight for this launch. Right now we are T minus 43 minutes. Okay, so we actually I need to change my settings here, change the countdown clock, but everything is right now looking good. Countdown is proceeding as per the plan. We are not facing any of such issues, and as they said, they have resolved the issue which caused the hot fire abort yesterday.
And welcome back,
So
Carolina. We're going to get into some
okay.
live chat questions here. Our first question, we were talking about Kodiak Island, the launch site, a little bit earlier, and we have a question in chat asking us how the rocket got up to Kodiak.
Yes, so one of the most unique aspects of Astra's launch system is that everything that you see on the screen that is not physically attached to the ground is shippable in standard shipping containers. The rocket itself fits inside a 45-foot shipping container, so we actually send everything up directly from our headquarters and assemble it on site. We also use this exact same test setup at our facility in Alameda, as well as where we conduct our static fire test, which is approximately 2 hours away from our headquarters, which allows us to test exactly like we are going to fly.
That's very cool, and that's a big part of Astra's not only flexibility in launch sites launching from anywhere, like with a concrete pad and an internet connection, but also eventually ramping up to a much higher launch cadence.
That's right. We see the opportunity for us to be able to set up a spaceport really wherever we need to meet our customer requirements and what they need and when they need it.
So another question in chat just asking how tall and wide is this rocket, and even if it can fit inside a shipping container, can't be too big, but it is a dedicated small launch vehicle. Can you tell us just a little bit about how big it is?
Yes, absolutely. We have a 43-foot overall length of the vehicle, and the diameter is 52 inches. For some other facts, the first stage has 5 Delphin engines, which are developed and produced, manufactured, and tested here at Astra. And the upper stage is powered by a single Ether engine, which is also an engine that we have developed, built, and tested entirely in-house.
And in fact, I believe that test facility is just in a building across from the one we're standing in right now. Those test cells were really cool to see during our factory tour last week.
That's right. It's really something to see an engine get built up in the morning and carted over to our test stand across the street and set up and often fired that very same day. It really helps us innovate and learn and gather test data and make improvements very quickly. So we are very thankful to have these amazing test facilities here at the former U.S. Naval Air Station in Alameda.
Another question from chat, are there advantages to having such a small launch vehicle when it comes to development and consumer construction of the rocket?
Yes, there are many, many advantages, I think, of having a small launch vehicle. First of all, a lot of what we're seeing in the satellite industry is that payloads are getting smaller, and while it's kind of like the airline industry. If you have a lot of passengers that all want to go to the same place, well, you know, those big jumbo jets, those large rockets really make sense to get there. But if you need to get there faster and you can't wait for that commercial flight, or if you need to get to a destination that's not quite as popular, then a vehicle like Astra's makes more sense. And we believe that the dedicated small satellite market is something that we're really interested in. And in terms of development, obviously it takes time to build and develop all of the parts that you see on the rocket and in our launch system. So the smaller rocket is faster to build, frankly.
Gotcha. Continuing on with questions in chat. Again, if you have more questions, tag us with @NASA Spaceflight. Throw those in the chat. We're going to keep going through those throughout today's countdown. And our next question is talking about where this launch is going. We know it's going to low Earth orbit, but can you tell us more specifically about what type of orbit the rocket is aiming to achieve today?
Yes, our target orbit today is an altitude of 415 kilometers and a 70-degree inclination. And again, we are sending a test payload for the U.S. Space Force as part of the Space Test Program. It will not be deployed as part of today's launch, but we do have a payload on board this flight.
So a very nice high inclination orbit, which is an advantage of launching out of Kodiak near the poles. I know we were talking about that in depth the last time as well, but not quite a polar launch per se. I'll keep going with the questions here. Here is a great one, and I know we have a camera view to show this, because some people in chat are asking about the guy with the mohawk. He's very popular in chat right now. Can you tell us a little bit about Mr. Launch Coordinator Chris Hoffman?
Yes, absolutely. So we can talk a little bit about these folks in our mission control. The gentleman with the mohawk you see there, that is Chris Hoffman, who is our launch conductor. He is responsible for overseeing the operations and following all of our procedures, and has the authority to call hold, recycle, or abort as required. And as a fun fact about Mr. Hoffman, on the side, when he's not launching rockets, he does run a cat rescue. It's rocketcatrescue.org and on Twitter, and so we love to support our space cats. And I can also talk a little bit about the other folks you see in mission control. To Chris Hoffman's right, which is our left in the navy blue long sleeve shirt, that's our launch director, Chris Thompson. He is the final launch authority and is responsible for the safety of overall launch operations. Then continuing counterclockwise at the top is our FAA officer, Luigi. And then we have our flight safety system coordinator, who is Lucas, and he is responsible for the onboard flight safety system. Next to him is Dan Wilson in the green shirt, who is our guidance, navigation, and control master, who ensures weather and wind trajectory information is up to date, properly loaded, and meets flight criteria. Then to continue, we have our Tango, who is Steve Lai. He is the vehicle controller, and so he's the one who is actually operating the vehicle. You will often hear him when we're listening into the countdown net. And then at the bottom of your screen, you see Chris May, who is our CDH, or Command and Data Handling. So he's monitoring and adjusting all of the software and is following commands from Chris Hoffman, our launch director, or our launch conductor. And then finally, in the googly eyes, that is our flight activities officer, Joshua Green. And he is responsible for keeping track of all of our activities during today's launch. So this crew of 8 folks is located here in our headquarters in Alameda, actually right behind our camera crew. Up in Alaska, we have a team of 6, our red team, that is on the ground helping to set everything up, and a huge shout out to them for all of the work they do. Having a small team to be able to operate the vehicle and set up our launch site has been a huge part of why we've been able to continue operating safely and efficiently during our ongoing COVID-19 pandemic. So we thank the red team for staying safe and for all that they do.
Absolutely, and we know we just went into a lot of detail with a lot of different people, but in reality, that's actually a very small team, relatively speaking, for launching a rocket, which is of course part of Astra's operations. So, but very cool for the introduction of our mission controllers today. We'll be listening in to them on the Countdown Net throughout the countdown. In the meantime, let's get back to some questions here. And we have one asking, is Astra hoping economies of scale will make up for the lack of reusability in this rocket?
Yes, definitely. That's one of the important things that we like to abide by at Astra, is that simple scales. So we are counting on making a mass-produced, low-cost rocket in our journey to achieve daily space delivery and to improve life on Earth from space. So we are hoping that the economies of scale and using typically more low-cost materials will help be able to deliver on that promise.
And then a second part of this question, talking about Astra's competitors in the small sat launch market. We know there are several new small sat launchers in various stages of development. What sets Astra apart from those other companies?
I think there's a lot of things that set Astra apart, but certainly I think our approach to using more low-cost materials, a lot of what you see on the rocket actually comes into our factory as raw sheet metal, and our in-house machine shop turns those parts into flight hardware. We tend to stay away from 3D printed materials and other costly materials in order to make the rocket as cost effective as possible, so we can help our customers get to space not only more efficiently, but also in a more cost effective way.
And we're looking live at our screen. We're seeing some vapors coming off of that black structure on the right. Can you tell us a little bit about, first of all, what is that black tower next to the rocket?
Yeah, so that is our strong back that supports the rocket, and you can see a lot of umbilical wires that connect the rocket and the strong back. So that's how we pump the propellant onto the vehicle. There's also communications links to the vehicle that are provided by the strong back, and then we do vent the system to maintain our pressures right where we want them.
And if I'm not mistaken, so that vent we're seeing from the strongback right now is probably liquid or gaseous oxygen, obviously. Am I correct in that?
I believe you are correct.
And of course, along the side of the rocket itself, we're seeing some condensed air and water vapor forming around the rocket as the super cooled liquid oxygen tank begins to fill and cools the air around it. We see that on a lot of different rockets around the industry, and Rocket 3 is no different. We're coming up on 33 minutes and counting, and we're going to keep going in with these questions. If you have questions, put them in chat. Tag us at NASA Spaceflight. You all know the drill. Let's take a quick break and listen in for activity on the Countdown Net and those pad mics as the countdown proceeds.
Okay, guys, I guess people are joining in, so let me just interfere in between and see, make sure that you all get to know about this launch. So first of all, this is a new rocket launch, which is you are seeing basically this is a test flight, obviously, but again, They haven't reached the orbit successfully yet, and they are hoping to reach it with this flight. Uh, okay, so and this rocket is carrying a test payload from US Space Force, and it is a non-deployable payload, and the payload weight is around 25 kilograms only. This rocket has 5 Delphin engines on its first stage, running on RP1 and LOX with the cycle of electric pump fed, and the second stage is the engine, has the ether engine, and that runs on a pressure fed cycle. So it's not a cycle only, but yeah, that runs on pressure fed um, configuration, and yeah, it is being launched from Kodiak Island in Alaska, mountainous region, and it is going to a polar orbit. Once a polar orbit, it's a 70 degrees inclination and 450 meters in altitude. So yeah, this is all it is about. Kind of no, Space Force is a thing which will happen for with every other country. I am telling you. Space is like another biome in which military has to have happen. Like air is a biome in which we know Air Force is there. Then the water is another biome. Then we have the naval forces. The land we have the normal military personnels, and so space is another biome, and we will obviously be having a space force also. Um, right now we don't see that as much, but the thing which will happen, but I don't like it at all. Space is a thing which unites everyone, and militarizing it will just make it more worse, I would say, but this
This
will
is
happen
Astra
for sure.
LC on countdown. We are holding at T-minus 30 minutes for propellant fill.
Have a hold in here for propellant fill as this. I guess the propellant feed lines were not able to feed properly, so that waiting for the propellant to
And as
fill
you just heard, a
properly.
hold has been called at T-minus 30 minutes and counting. We will stand by for more information and provide it when we have it. Again, there's a fair bit of time in today's launch window, so we'll stand by and hope for an attempt later this window.
Yep, that's right. We just got the word that the hold was due to propellant load. So as you can see, we are filling up our tanks, and we are holding to catch up to the point we are in our countdown.
It yes, maybe a type of sensors, but again, the second stage will remain in orbit for some time, okay, for some months. So you can kind of have sensors also, but instruments also, like a demonstration instrument which you can have, which you want to expand to bigger satellites. So you can just test it on this payload, on this rocket. Yeah, we actually don't know what they are trying to do with this one, but we just know that won't deploy, and it weighs around 25 kilograms. That's it. Let's hope that this
All
thing,
good so far.
that they load the propellant quickly, because there's already been so much time which has been taken for this launch, and I would want this to launch as quickly as possible, but with
Also
proper
looking good.
procedures.
So while we are waiting for this hold to continue, while they're waiting for propellant load to catch up on the vehicle, we're going to take a look at an interview from last week where I sat down with Astra's founder and CEO Chris Kemp to learn a little bit more about Astra's mission and today's launch. So let's take a look at that. Hi everybody, I'm Thomas Burkhardt with NASA Spaceflight here at Astra's headquarters, and I'm here talking to CEO Chris Kemp. Chris, thank you so much for joining us today.
Yeah, thanks for having us.
Thank you for coming on to NASA Spaceflight Live. That was an absolute pleasure. Some stuff has happened since, and we're getting ready for the launch of Rocket 3.3. What are your expectations for this upcoming launch?
Well, we hope to learn a lot. This will be a test flight of our improved Rocket 3. We'll be taking a test payload from the Space Force, and hopefully we'll have a full flight, so we'll be able to collect a full set of data for them.
And how confident are you in the success of Rocket 3.3?
Well, I think we'll learn a lot, and I certainly hope we get a full flight in. A lot of changes have been made, and we've incorporated all of the data from a complete flight back in December into this new version. And regardless of what the outcome of the flight is, we'll take whatever we learn, we'll make whatever changes, and we'll fly again.
What shift in the industry at large is the most important to you, and what is Astra's role in that?
Well, I think the ability to quickly iterate. We're seeing both Astra and other companies quickly make another version, learn as much as they can, and then iterate. And it's really particularly easy to do with such a small launch vehicle.
So you mentioned launch sites. What kind of places are acceptable for Astra's rockets to launch? Are you limited to the places we traditionally think of, normal launch ranges, or is there infrastructure or regulatory infrastructure in place to launch from pretty much anywhere?
Well, we can basically launch anywhere we have a license, which means we just need to find a place where we're far enough away from population centers to not bother people. And we're investigating over a dozen different locations, both domestically and abroad. Our system could be completely shipped and unpacked, and we can launch a rocket within a few days. So you can kind of see how that enables us to be very flexible. And we're going to continue to be able to develop and iterate on the entire launch system, including the spaceport, at that same rate.
So just on Thursday, I believe Astra received their authorization to operate out of Kodiak, Alaska through 2026. Can you talk a little bit about that?
That's right. We received a launch operator's license from the FAA, and that allows us to launch this version of the vehicle through 2026. It means we don't have to go through a licensing process for every single launch, but as long as we're launching out of the trajectories with the current spaceport, current rocket.
What kind of forward work is needed to start launching these rockets from more non-traditional locations, things that are not already established spaceports?
Really, from our perspective, it's just a licensing issue. So we just need a fence and a concrete pad, and we bring our infrastructure in and we launch. So very little actual work needs to go into setting up the site. A lot of work needs to go into make sure that we're not going to interfere with the community and we're not going to cause any disruption. So we try to find places that are away from cities and population centers, typically in coastal areas.
So on NASA Spaceflight Live, you mentioned a point-to-point cargo delivery system as part of the future of Astra. But I believe Astra is looking externally for the re-entry part of that. Can you talk a little bit about that decision?
Well, I think that Astra's focus right now is in mass producing and scaling launch operations. That focus means that we're not off building larger rockets. We're not going to try to put people on our rockets. We're not going to try to work on re-entry systems. And so it's a natural area where we can get something to space. We're going to partner to try to figure out how we get it back to the Earth safely.
You know, some other companies have made that same promise of saying, listen, we're in the small sat launch business. We're never going to go to bigger rockets. Some other companies have ended up changing their mind. How set are you on that? Is that something you're completely off the table or open to potentially, if the market calls for it, Astra's serving into that market as well?
Well, we've already sold over 50 launches, and we're very focused on what our customers ask us for. And right now, there is an overwhelming demand for point-to-point launch services. And what that means for us is we can't scale fast enough, and we can't focus more attention on continuing to drive the cost down and the scale up of the launch services that we provide today.
What do you believe is the sweet spot capability for a small sat launch vehicle as far as size is concerned?
Well, for Astra, it was the smallest rocket that would meet the needs of today's market today. And that's the 50 kilogram class Rocket 3 series. As we start to see more large mega constellations come online, that sweet spot moves to around 150 to 200 kilograms. Where we ultimately seeing it settle out from an economic perspective is a small rocket that can deliver approximately 500 kilograms to a mid-inclination orbit.
Do you think that you'll fly a lot of missions that are basically a 3-stage vehicle similar to Rocket Lab's Electron once you have that spacecraft bus coming online?
Yeah, we think that having more ability to add capacity to the upper stage gives us a lot more flexibility. So the Apollo Fusion engine is a great example of a technology that lets us have more precision and more capacity.
And so these design changes or designs that you're looking towards and the evolutions that you're aiming towards, how does that market and how does that compare to your competitors that are also in the small sat market, which is growing seemingly by the day?
Right, well, what we're trying to do is focus on flight rate above all else. So if we can fly, for example, next week, we'll take what we learn. So that next rocket will benefit from whatever we learn.
On launch day for this upcoming rocket, how is that going to look different from the previous launch as far as personnel involved, the countdown process as far as automation is concerned?
We're really very similar to the previous launch. We have about a half a dozen people up in Alaska. We have about a half a dozen people in a launch control room here. And we're going to be running the launch using a lot of the same software and systems that we used in December.
So what is the objective of this upcoming launch with regards to Astra serving the Space Force in the future?
Well, this will be the first launch of an orbital launch system. So it'll be a test launch being performed for the Space Test Program within the Space Force. What we'll be doing is we'll be launching to a very specific orbit and inclination. We'll be watching that closely. We have a test payload that's been instrumented. So we're going to be looking at the vibrational environments, the acoustic environments, the thermal environments, so that we can give all that data to the Space Force. So this payload will not be deployed from the spacecraft, but we're going to measure our ability to get it exactly where it needs to go.
It was great to sit down with Chris Kemp earlier last week prior to today's launch attempt and the launch attempt yesterday. Just a pleasure to sit down and talk with him. If you are just joining us, today's launch attempt is currently in a hold. You can see we're at T-minus 30 minutes and holding, as teams are just working to catch up on their propellant loading operations before continuing into the really business end of the countdown. In the meantime, Caroline, if it's okay with you, let's dive into some more questions.
Keep them coming.
All right. So a question in chat asking about what do you use to light those Delphin engines on the first stage? Talk a little bit about that.
Sure. So again, our first stage is powered by 5 Delphin engines that are developed and built and tested here in Alameda. Each engine produces 6,500 pounds of thrust at sea level and is powered by liquid oxygen and kerosene. And we actually have a ground-based ignition system, which is one of the unique features of our vehicle. So in order to make the rocket as simple as possible, we try and put more of the more parts into the ground that doesn't fly, so they can be heavy. And so we keep the engines as simple as we can. So we use a ground-based ignition system.
So if I understand that correctly, it's about taking as much mass as possible for all the systems needed to begin a rocket launch and putting them as many of them on the ground as possible so that once you lift off, you're not carrying all of that mass with you.
That's right. We can better use that mass to increase our payload capability.
And on the other side, you also reduce the complexity of the part that is flying, right?
Exactly. It's a win-win.
Absolutely, and as we've mentioned many times, simple scales, right? Keeping going with the questions here. We do have a question about what propellants does this rocket use to feed those engines?
Yes, so both the first stage and the upper stage engines are powered by liquid oxygen and kerosene.
Gotcha, and when we're looking at a screen there, we're seeing some gaseous oxygen venting from those tanks, and the frosty part of the rocket is that super cold liquid oxygen tank above the ambient temperature kerosene tank. So that's what you're seeing on your screen. And again, we'll see that continue to get more solid frost on that upper part as the propellant loading operations catch up and we can get towards releasing this hold. And we talked a little bit about this yesterday, but that ice that's kind of forming the frost on the outside of the rocket, that's a negligible amount of mass that shouldn't affect the flight of the rocket.
Yes, that's right. And you'll potentially see large chunks of ice as it forms fall off the rocket that is expected.
Diving back into some more chat questions. F1 here, do you believe that reusable vehicles, full or partial, are necessary to achieve the goal of daily spaceflight, or is it possible to get there with expendable vehicles?
Well, as we've talked about, our strategy really focuses on expendable vehicles. We are not pursuing reusability at this time. We believe that we can make a rocket that is much cheaper and more efficient if we focus on expendable vehicles.
Gotcha. Another question here. There is a lot of talk about space's commercial future, and what is Astra's role in this new era of commercial spaceflight?
Yeah, certainly. So Astra's mission is to improve life on Earth from space, and we do that by providing services to satellites that are helping to observe and connect and improve the health of our planet. And so what we hope to offer in the future of commercial spaceflight is unprecedented access through daily space delivery at affordable prices by using our launch system that is manufactured at scale.
We also have a question here asking, and I think I might be able to even field this one, how many cameras do we have tracking the rocket? Are they all automated, or do you have any camera operators? I can give a quick shout out to Mr. Brady Keniston, one of the NASA spaceflight photographers out there with Astra today. Actually, you're looking at his camera view. The rocket will pop out from those trees after liftoff. So we've got a human camera operator out there, as well as a lot of those robotic cameras. And I believe there's one other tracking camera that's actually pretty cool to talk about.
Yes, we do have a tracking camera on our dish antenna as well. So that is the system that we use to provide radio link, and so we have that camera ready to go. So we have lots of camera feeds that we hope to be able to show you during flight.
And if I understand that correctly, that camera view is literally on the telemetry tracking dish, which of course has to be pointed at the rocket. So by product, you have a camera pointed at the rocket.
It is simple scales.
Yeah,
like
there you
say.
go. We're also seeing some really cool onboard views. There's an onboard camera on the rocket's first stage. You can see the frost forming on the outside. We talked a little bit about this yesterday. Don't know how reliable that camera feed will be once the rocket actually lifts off, but assuming it does work, we're going to show those as much as possible because they are really cool views. And back to our kind of ground-based camera views again. This countdown currently in a hold, so we're taking some questions in the meantime while those propellant loading operations catch up so they can resume the countdown. Our next question from chat asking about the Kodiak, Alaska launch site. Looks pretty beautiful out there now, but a question in chat asking, is this launch site still usable in the middle of winter?
Yes, absolutely. Our last launch out of Kodiak was actually in December in the middle of winter. So it is a different picture, a lot snowier, but no less beautiful. Our red team tends to be bundled up in beanies and big coats, but we do use this launch site and have operated at this launch site year round.
And you mentioned the red team. We have a question in chat about talking about the red team leader. Who's the red team leader today? And just tell us a little bit more about the red team out there in Kodiak.
Yeah, so our red team leader is Adam Frisch, who I'm sure is very excited to get this shout out right now. So kudos to whoever friend posted that question. And our red team is a team of 6 folks who go up to Alaska with all of our launch support equipment and our vehicle, and they are the ones who set everything up and ensure the safe operation of everything on the ground. So it's pretty remarkable that it only takes 6 people to set up the entire launch site that you see in front of you today.
And the other half of the launch operations team in Mission Control, can you tell us a little bit about where that Mission Control is situated?
Yes, so our Mission Control, we spent a few minutes ago, spent some time walking through those different roles, but that Mission Control team is right here at our headquarters in Alameda. They're sitting directly behind our broadcast area, if you've seen that. This is in our factory, and in addition to these 8 folks, we have about a dozen engineers who are the responsible engineers for the different systems on the rocket. They're the folks who will be polled during our go, no-go polls throughout our countdown, and they are actually also dispersed throughout our factory office. We have a great setup where they're able to be at their desks with a light to notify folks that they should not be disturbed and are in operations. So we are a very lean team as we control the vehicle and operate it for launch.
I have another question in chat here asking, are there any superstitious rituals done before each of Astra's flight?
Well, I don't know if there's any official rituals, but we certainly have our own little superstitions here. Our launch conductor, Chris Hoffman's mohawk, tends to change color as we enter a launch campaign.
Okay.
There's quite a few folks in here who are wearing their lucky socks. I myself listen to some pump-up music on my drive-in particular No Scrubs by TLC. It's for good luck today.
Excellent.
So we do have our share of fun traditions that we try and keep our fingers crossed for a smooth ride to orbit this afternoon.
Absolutely. I can definitely understand that no scrubs philosophy. Hoping for a successful countdown today. Continuing on with some questions here. One question about what this rocket's name is. We're calling it LV0006. We're also calling it Rocket 3.3. You want to explain about that a little bit?
Sure. So Rocket 3.3 is the version number of this rocket, and LV0006 or LV0006 is the serial number of this particular rocket. So that Rocket 3.3 number refers to the precise configuration of this rocket, and that includes the changes that we made from our previous flight in December, which was for Rocket 3.2. But LV0006, LV6 is the name of this vehicle, and we're focused on that serial number because we hope to make many copies of this same vehicle, and we also hope to continue to increment those numbers and someday be at LV 9999 and beyond.
Excellent. Continuing on with the questions, another question about the engines that we're using. We know there's the one type of engine on that first stage, there's 5 of them, and then a different engine on the upper stage. Want to talk about those a little bit more?
Absolutely. Always happy to talk about our engines and our fantastic propulsion team that develops them. We've talked quite a bit about the first stage Delphin engines, but the upper stage engine is Ether. It is a pressure-fed engine, and we have one of those powering the upper stage of LV6. It has 740 pounds of thrust at vacuum, and it is also powered by liquid oxygen and kerosene. And again, just like the first stage engines, our upper stage Ether engine is also developed, built, tested, manufactured entirely in-house by our team here in Alameda.
Gotcha. Another question about what we're looking at on screen here, actually. Is there a flame diverter as part of that launcher underneath the rocket?
Yeah, it's a little difficult to see, but in that sort of cube-shaped structure that the launch stool that the rocket sits on, there is something that kind of looks like a slide. That is the flame diverter for the rocket.
Yeah, we can make it out just in this camera view. You can kind of see it on the bottom there. It'll be nice and obvious at engine ignition. You can see the thrust getting diverted out to the side. So once we reach that milestone, it'll be even more visible. But yeah, you can just make it out in this camera view a little bit.
And we also do have a water deluge system. The deluge test will happen at about T-minus 20 minutes or so as one of the final steps before we enter our terminal count. And that water deluge system serves the purpose of suppressing sound and as well as getting rid of any flames that may fall astray to protect the beautiful landscape and preserve the safety of people and property at our launch site.
Right now, we're continuing on with some questions from chat. In the meantime, if you're just joining us, we are at T-minus 30 minutes and holding. Team's just working to catch up on some propellant loading operations prior to releasing the hold. So we're standing by for a new launch time once that hold can be released. Taking another question from chat, Carolina, someone's asking, what is the next Astra mission?
Well, we are hoping to and on plan to complete 3 missions this year, so you'll have to stay posted on our news for updates about our next mission, but we plan to complete 3 flights this year.
Gotcha, and that'll be more of a monthly launch cadence, which is a part of that ramp up towards the eventual goal of daily launch operations.
That is our hope. And
we have a question about that. Someone asking about what are Astra's kind of thoughts or opinions about the environmental impact of launching these non-reusable rockets, these expendable rockets, at a daily launch cadence?
Absolutely. So we do have most of our rocket is made out of aluminum, which does corrode in salt. So it does degrade. The first stage does degrade when it falls into the ocean. Also, as a smaller vehicle, we are much lighter and can use a lot less fuel. And as we are able to calculate and project where the first stage will land during and after its flight, this not only serves the purpose of helping us to ensure safety, but we are also looking at long-term options to minimize the ocean debris. And similarly, in when it comes to space debris, the materials that we use and the satellites we launch are not intended to remain in orbit forever. And so when the upper stage and theoretically any payloads we launch do fall out of orbit, they will burn on re-entry.
Gotcha. Continuing on with more questions here. We do have one asking about these hoodies. I'm wearing one right now. I don't know if we can cut to it really quick. I can show off the Astra on the shoulder. If there we go, you see. So we do have a question in chat asking, how can we get these hoodies?
Well, we don't have an Astra merch shop at the moment, so the only way to get one of those hoodies is to be an Astra employee or be one of our close friends. So you can learn more about joining the Astra team at astra.com/careers. We have many roles open and are hiring very quickly as we scale up our team and continue to work towards our goals. So if you are interested in working with us and getting cool hoodies, we've got cool water bottles too. So please check out astra.com/careers to learn more about how you can join our team.
So as you can see right now, it is still on the hold. They were on the
And we
because
also have an update to share. We are currently in a T-minus 30-minute hold while they are working on catching up on propellant loading operations. We are hearing that we are getting close to releasing that hold, so we will stand by for a new T0 and provide that as soon as we have it. But stand by for a release of the hold before too long. To kind of finish off that thought about joining the Astra team, we each have one specific question. Does Astra anticipate hiring any DevOps engineers in the near future? Asking for myself, says Alexander.
Well, Alexander, we have so many open roles that I don't know to speak to specific ones, but you can check out our careers page and see the available job postings.
A relevant question asking how many people work at Astra currently?
We are growing so quickly, it is kind of hard for me to keep track, to be honest. But we are, as we've said before, we are still a pretty small and nimble team of a couple hundred folks. So we are growing rapidly, and that number is constantly changing.
And again, as we are getting close to the release of this hold, hopefully, let's go ahead and listen into the countdown net as controllers get ready to resume the count.
so we are getting release of the hold. So the hold was there to load up on the propellant on the rocket. Was not you can say kind of say that the feed lines and propellant feed lines were slow, and that's why not feeding the propellants properly. But now they are just waiting for the fuels to be full, and then they'll resume the countdown, which we can see that it is kind of full because the venting has increased, and whenever the venting increases, that indicates that it is coming close to the topping of stage. So yes, just making sure the team making sure that everything is good, propellant levels are good, and then they will release the hold when they have the new P0. hmm They're surprised on closer inspection they don't have more dark lines on the arch. uh I guess they have enough markers station exact. hmm well, they all they already launched it previously, the 3.2 rocket launch, and the first stage performed properly. So I guess they know what they are doing with it. That uh, yes, that is performing now. Like I have actually asked this question previously in my streams also, but again I'm asking that you can see the frost on the upper part of the section,
Astra
but
LC on countdown will be picking up the count with 30 minutes remaining at the top of the hour.
okay, so I guess know what they are trying to update my clock.
And as we just heard, again, we're at T-minus 30 minutes and holding, and it sounds like they're going to aim to release this hold at the top of the hour, so 3 o'clock p.m. Pacific time, which translates to a new launch time of just about 3:30 p.m. Pacific time. Again, we're standing by for the hold to actually be released, but that is our new no earlier than launch time, 3:30 p.m. Pacific time. And so we will stand by for the countdown to resume in just under 2 minutes.
Okay, yeah, I was saying that the frost is on the upper section but not on the bottom section. The reason being the liquid oxygen is there on the above section because the cryo tanks, the liquid oxygen needs cryo temperature. The RP1 does not need that much, so that's why the frost you can see the upper section. But the question is why on the upper section, why the liquid oxygen not situated below? And the basically what I'm saying is why the oxygen tank is not below and the RP1 tank is not above it. Why the configuration is like this? Yes, I have already answered this question, so I would expect something. Don't like to sound like a teacher, but yeah. Okay. And we have the countdown. We have our countdown
LC on
resumed.
countdown picking back up. We are currently at step 102. FTS, can you verify that mission data load values are ready to be loaded onto the AFTU?
FTS confirms the mission data loads. They're ready.
Please run CAS software as required.
CAS is running on both AFTUs.
Safety, confirm that you have a head count on all Astra employees and guests in Kodiak.
Safety can confirm, roll call on all guests. I have 2 at AMC, the rest are with me.
Copy, thank you.
I asked why the bottom section is fuel and the above section is oxygen, and why not reverse? Bottom oxygen and above fuel.
And as you've
That's
just
what.
seen, we have released the hold. We're at T-minus 29 minutes and counting now, heading towards a new T0 of 3:30 p.m. Pacific time for the launch of Astra's LV0006. Carolina, can you give us an update on how the countdown's proceeding?
Everything is proceeding nominally. So we have released that hold, and we have made all of our operational corrections to address the issue with yesterday's abort. So everything will hopefully proceed smoothly from here.
As we get closer to the business end of the countdown, we're going to want to turn our attention to the countdown net and the launch proceedings. So we're going to get through a couple more questions here before we get to that point. A question asking about the process for getting the shipping containers out to the pad look like. Is it trucks, planes, boats? What's used to get all that material out to Kodiak?
So we will generally ship everything in standard shipping containers that will be trucked and shipped by boat, but we have also shipped our rocket by air cargo in the past and do have that capability as well.
And on a related note, Astra is known for this mobile launch system. It's a very defining part of the Rocket 3 architecture. What existing infrastructure is needed at Kodiak to host all of those systems?
Yeah, so we like to say that all we need is a concrete pad and an internet connection, and that's pretty true. We have the capability to bring pretty much everything else we need to the launch site in order to set up and fly.
Gotcha. And another question about that launch system, asking how does the rocket firing on the stand affect that launcher system, and is there any refurbishment needed between engine firings?
So as we've mentioned before, that everything that you see, we pack up and use to test at our headquarters in Alameda, at other test sites near our headquarters, as well as shipping that up to Kodiak. So we do have a pretty well-established procedure for checking out our systems and making sure that any repairs can be made. But generally, these systems are pretty rugged, and we pack them up and send them on to their next destination. So after the ignition yesterday, our systems continue to be in good shape.
Another question about the launch site, asking what are the two, in parentheses, towers for?
Yeah, so this black tower that you see on the left side of the screen now, and now you
There you go.
see both of them on either side. That's our lightning protection system that prevents the rocket and the launch system from being struck by lightning.
It would not be a NASA spaceflight stream without talking about lightning protection system. We have to hit it every time. It's basically in our contracts. Continuing on with the questions here, is this a cargo-only rocket, or could Astra one day carry a human capsule?
We are focused on sending cargo missions. That is part of how we're able to focus on low-cost vehicles and manufacturing techniques, because we don't need to provide all of the life support systems you need to send people. We're pretty fragile cargo, so we're sticking with satellite payloads.
Gotcha. Again, if you have questions, throw them in the chat. Tag us at NASA Spaceflight. We're coming up on T-minus 25 minutes and counting, and that terminal count starts at 15 minutes. So we've got just under 10 minutes left until we get into the really business end of this countdown, and we're going to want to keep our focus there once we reach there. Right now, you can see the rocket is propellant loaded. You've got the liquid oxygen tank, nice and frosty, in the middle of the rocket. Below that is that bare aluminum for the kerosene tank at ambient temperature. Above that, you can see the inner stage and the payload fairing. Those two together are encompassing the upper stage. And the mass simulator payload, the test payload from the United States Space Force's Space Test Program, which of course will not be deployed from today's launch. But that is the vehicle you're seeing next to the strong back with all of the umbilicals. You can see some venting from the liquid oxygen and the gaseous oxygen venting out of those systems at this beautiful launch site in Kodiak, as we are counting down towards the launch of LV0006. Yesterday we had an abort at T0, and we have a question in chat asking about what happens to that propellant after you have to scrub a launch.
Yes, so yesterday after we scrubbed our launch attempt, we essentially pump the propellants back off the rocket and start fresh today. So the same system that we use to load propellants onto the vehicle is also set up to be able to pump them off in a safe way and not dump them overboard or anything like that.
So everything that we're not seeing, vented from the vehicle, obviously there's some oxygen venting because that's how you keep tanks pressurized at the right levels and things like that, but all of those other commodities just come right back off the rocket and are used again.
Mm-hmm, that's right.
Gotcha.
So basically here, if you notice guys, that I just noticed this thing by seeing venting. There is no as such venting for the rocket. I mean, the vents are not situated on the rocket but on the ground supporting equipment. That is so cool. That's why you are seeing this thing here. I mean, wow. As she said that they try to, put as much equipments or, things possible onto the ground support only, so that they don't have to, finally work with the that extra mass.
Igniter is unchanged. 106
yes.
Victor 9.
106 Victor 9. Loading. Loaded.
That's why you
Thank you,
can't see the
Delphin.
vents
Ether,
from
can you
the
please provide
rocket
your
but from
config?
the ground support, because
Ether
they are
is
literally
101
situated on the
Victor
ground.
12.
Ether controller 101 Victor 12. Loading. Loaded.
Elder's good.
Guidance, what is our latest guidance config for the vehicle?
We're going to use guidance version 5 Victor 131 L4 balloon.
Copy that. Guidance version 5 Victor 131. Loading. Loaded.
Copy, thank you all. The config is late loaded. Tango in VB1 turn on off PDBs. Please give me a GNC setup. Call out when complete.
Copy that. Setting up.
And what we just heard, they have loaded those software engine configurations into the rocket as we get towards 21 minutes and counting now. And that was the Tango call sign, which we have a question in chat about. We heard some callouts during the countdown yesterday. Tango is always ready. Is Tango still ready?
It appears that Tango is still ready. And that Tango is our vehicle controller, Steve Lai, and he is loading that software configuration onto the vehicle. We're getting weather data through weather balloons during our countdown procedure, so we always like to have the latest and greatest before we attempt to launch.
I don't want to spoil any future NSF developments, but I must say we have some cool audio bits in that opening sequence, and I think we might have found a new one here at Astra because that's just so cool. Another question from chat here asking about those Apollo engine thrusters, the Apollo Fusion thrusters. Can you talk a little bit about that?
Yeah, so the Apollo Fusion is a company that Astra recently confirmed the acquisition of back in July, and we are very excited to have that technology and team on board. They share a lot of, their approach is very similar to a lot of our philosophy at Astra about rapid design cycles, focusing on ease of manufacturing and assembly. And this past week, Apollo Fusion Thruster did ignite in orbit, which is an amazing accomplishment for that team. And together, we're working on providing rapid and low-cost access to space.
Gotcha. We're coming up on T-minus 20 minutes and counting, just 5 minutes away from the beginning of the terminal count, so a brief status update if you are just joining us. We are targeting a liftoff time of 3:30 p.m. Pacific time after a hold for some propellant load operations to continue. All systems appear to be operating nominally right now. Carolina, can you just give us a status update of where we're standing now?
Yes, we're just inside T-minus 20 minutes, and as you heard a few moments ago, we have loaded our final software configuration. The team will now be working on spinning up our first stage engine pumps, and we'll be getting into our final preparations, including our water system, our water deluge system test, and that will signal that we have entered the terminal count at T-minus 15 minutes.
And if you're tuning in after yesterday's attempt, we know we did have an abort at just about T0 yesterday due to a engine configuration, and they have applied that corrective issue to come back towards today's launch attempt. We also had a hold during the webcast today of the propellant loading operations just catching up before we released and targeted this new 3:30 p.m. Pacific time launch, and everything proceeding nominally now. This is the test flight for the U.S. Space Force's Space Test Program, a test payload on board today that will not be deployed, but Astra's third orbital launch attempt with LV0006, the debut of the rocket version 3.3. As we come up on 18.5 minutes, we're going to go ahead and listen in as the teams prepare to enter the terminal count at T-minus 15 minutes.
The oxygen wildflower says this is just the oxygen and it's in the rocket. Cooling externally to keep cryo chill inside. No, basically what is happening here is the vents are situated on the ground support. What do I mean by that is you can see there are some feed lines going inside the rocket, and basically the place where the vent was supposed to
Delphin,
happen.
please confirm status of ESC flags.
ESC flags are nominal.
Tango, toggle dry spin both.
Dry spinning both.
Okay, so yeah, I was saying wherever the vent was supposed to be situated on the rocket, there the pipes go and
Left idle.
take that
Delphin, please
vents
confirm results of pump
onto the
spins.
ground support.
Pump spins are nominal.
Copy, thank you. Tango, deactivate AV1 power ESCA dry spin.
Machine deactivated.
Delphin, confirm your system is ready for launch.
Delphin is go for launch.
Ether, confirm your system is ready for launch.
Ready for launch.
CDH, please set aux ISO target pressure back to 90 psi.
Set.
Tango, verify vehicle looks ready for launch aside from tank levels and pressures.
In work.
GNC, confirm wind profiles still look acceptable for launch.
Confirmed, wind profiles look acceptable.
Tango on countdown, vehicle looks good.
Copy. Tango on the buttons interface, please toggle spark for 30 seconds.
Copy that. Sparking in 3, 2, 1, spark. Spark off.
Delphin, please confirm current on all 5 igniters.
Current draw is nominal.
Copy, thank you. This takes us into our water test. Tango in the water system machine, toggle deluge to on. You will toggle back off on my call.
Copy that. Deluge on now.
Could see the deluge, which will be interesting to
Off.
see. There
Off.
you go.
Good deluge test. Tango in the water system machine, toggle pump full to false.
False.
Team.
And you just saw the successful water deluge test as we have entered the terminal count at T-minus 15 minutes and counting. Carolina, let's go over those details for today's mission now that we've entered terminal count.
Sure, Thomas. LV-6 is Astra's third orbital launch attempt and a demonstration mission for the United States Space Force Space Test Program. It's also our first commercial orbital launch, meaning the launch is being conducted under an FAA commercial launch license. Our goal today is to successfully reach orbit with a test payload that will not be released. This orbital demonstration launch allows our team to verify numerous upgrades to our launch system since Rocket 3.2 in December of 2020. Today's launch is an important milestone in our work at Astra and a crucial step towards launching our next payload. You can find more information about the flight at our website, astra.com, and we explain more about our approach to reaching orbit and our other objectives for today's mission. Before we get further into the count, I'd like to give a big thank you to the entire Astra team and their families watching with us today. We really couldn't do this without you and all of your support, so thank you again. As a reminder, back in December, Rocket 3.2 successfully passed the Kármán line, the 100-kilometer altitude that's commonly used as the demarcation of space. We learned that Rocket 3.2 shut down about 12 to 15 seconds too soon after depleting its fuel, only half a kilometer per second short of orbital velocity, which sounds like a lot, but that is so close. And since then, we fine-tuned the mixture ratio between our kerosene fuel and our liquid oxygen to propel us the rest of the way to orbit.
As we get closer to liftoff, let's talk a little bit about the vehicle that you're going to hopefully see liftoff in just under 13 minutes. LV0006 is a 2-stage launch vehicle, each stage running on liquid oxygen and liquid kerosene. The first stage is powered by 5 electric pump-fed Delphin engines. They each produce 6,500 pounds of thrust, and those are made in-house by Astra. The upper stage, also built in-house by Astra, powered by a single pressure-fed engine called Aether.
To increase the payload capacity, our current rocket has several upgrades from our last launch vehicle, Rocket 3.2. In LV-6,
No.
and we've just received
So guys, we are getting close to the launch. We are right now at a hold right now. So we are at a hold again. Let's hope now this hold does not mean we had a hold yesterday also, but again
Looks
the problem now because it's now inside the terminal countdown and then they have to recycle it at t minus 15 minutes. Oh, I think that's not a good. We can't simply hold it at 12:30. They will recycle it at 15 now. Okay, have to wait and see how it look like, but it's always not good to see a hold at a terminal down because you then need to recycle and go with those procedures again. But was not actually inside t minus 10, so I guess not much procedures were made. Have to wait and see.
Software configuration changes that were made, and we expect to be picking up the count shortly.
Okay, cool.
So we'll listen in on the countdown to hear that update.
Now they have to get the new T0 also. Whenever there is a hold, then what director or should I say the trajectory engineer has to do update the guidance and navigation system for the rocket, because they have set the guidance and navigation at that particular T0, and whenever there is a hold, they need to update the you can say the model, the atmospheric model at that point of time, the predicted atmospheric model. So now since they are at a hold, so I guess they will again load
this
the
is Astra
software
LC on
configs.
countdown. We have resumed count. We held briefly to make a minor change to an engine configuration. Picking back up in terminal count at step 137. FTS confirm. Astra FTS is still enabled and nominal.
FTS confirms.
And as you can see, the hold has been released. We're back at 13 and a half minutes and counting. Just a little brief hold, but back into the countdown. We are in terminal count for Astra's launch of LV0006. That gives us a new T0 of 3:35 p.m. Pacific time.
And prior to the hold, we were talking about some of the changes to this vehicle. So to increase our payload capacity, this vehicle has several upgrades from Rocket 3.2, which we launched in December. In LV6, we've stretched the first stage tank to increase propellant capacity, reduced the mass of the upper stage, added additional sensors to gather more data about flight environments, and consolidated over a dozen individual components on the upper stage into one single assembly. The main propellant load has been completed, and we're continuing to top off oxygen prior to launch. And so, as we've mentioned before, the vehicle is now in terminal count, so we're performing the final checks before we give a go for launch. We've talked a little bit throughout this countdown about the red team, but I also want to take another moment here, if you're just joining us, to recognize them. The rocket is controlled from our headquarters here in Alameda, but we do send a red team of 6 Astra personnel to the Kodiak for that launch. And because our rocket and support systems were designed with simplicity in mind, we only need a very small team on site for the launch. It also helps us limit travel, which has been a key consideration during the ongoing COVID-19 pandemic. All 6 members of the red team are taking regular COVID-19 tests to protect the health and safety of everyone involved in this mission. We are at just under 12 minutes to liftoff, and we'll continue to listen to the countdown net. In a few moments, we expect the launch team to conduct a go, no-go poll to proceed into tank pressurization and launch.
we are looking good with the launch right now. T minus 11 minutes and
Deactivate Ox1 OV201 first fill.
Off.
Ox1 OV102 return.
Off.
Ox1 OV100B101B fill.
Off.
Toggle off and deactivate Fuel 4 operate.
Off.
Fuel 3 supply.
Off.
Fuel 1 FE300 upper fill.
Off.
Fuel 1 FE200 first.
Off.
AV1 radios.
Off.
AV1 rocket support cart.
Off.
Please confirm the following are still enabled and running. 0 stop purging.
Active.
AV1 manage polling.
Active.
AV1 manage power systems.
Active.
All flight helium machines.
Active.
VB1 first stage power.
Active.
VB1 upper stage power.
Active.
VB1 turn on off PDBs.
Active.
Water system.
Active.
Tango, at this time, I would like you to enable the launch machine.
Active.
Toggle locks topping.
Toggled.
Okay, it's exciting times now, guys. It's happening finally. T
On
minus
countdown
10
team,
minutes.
this takes us to step 144. This is the poll for tank pressurization and launch today. After this point, any system issue must be called as a 3-word hold. If there are no concerns for flight, call go. Otherwise, call no go. Red lead.
Red lead is go.
FTS.
FTS is go.
Delphin.
Delphin is go.
Ether.
Ether is go.
Odin.
Odin is go.
Inco.
Inco is go.
Ace.
Ace is go.
Launcher.
Launcher is go.
Orbit.
Orbit is go.
Booster.
Booster is go.
GNC.
GNC is go.
FAO.
FAO is go.
CDH.
Go.
Tango.
Go.
Safety.
Safety is go.
LD.
LD is go.
LC is go as well. Tango and AV1 manage polling. Set us into ground only mode, please.
Ground only.
And as you have just heard, the poll has been conducted and the Astra team is go for launch.
If you are just joining us, we are currently just under 9 minutes away from liftoff for Launch Vehicle 6, or LV0006. This rocket is an orbital class vehicle, so if everything goes well, it is fully capable of making it to orbit. However, as a reminder, today's mission is still a test flight for Astra.
Yes, historically, achieving orbit is very difficult, and for this reasons, we are very realistic about our expectations. Today is our 3rd attempt to reach orbit and our first test with a sample payload provided by the Space Force to simulate mass, and again, we will not be deploying this test payload. For the next several minutes, the team is loading the final flight software onto the vehicle and going through our final checklist for launch.
Right now, we're at just about T-minus 8 minutes and counting. As we enter these final minutes of the countdown, we're going to turn our attention to the countdown nets, to the rocket on your screen, and I'm going to hand off commentary to Carolina for Astra's 3rd orbital launch attempt. Carolina, it's all yours.
Thanks, Thomas. The major flight milestones that we will encounter during flight are displayed on the left for you to follow along. At T-minus 3 seconds, the 5 first-stage Delphin engines will ignite, and if the engine data looks good, the hold-down mechanisms will release at T0 and the rocket will begin its trip to space. At T plus 12 seconds, the rocket will begin pitching downrange to fly south over the Pacific Ocean. LV6 will reach max Q, which is the period of maximum aerodynamic pressure on the vehicle, at T plus 1 minute and 15 seconds. Main engine cutoff, or MECO, is the end of the first stage burn, and that will occur at T plus 2 minutes and 50 seconds. This is followed by fairing separation and stage separation, and at this point the rocket will be in space. After stage separation, upper stage ignition occurs at T plus 3 minutes and 5 seconds, the beginning of an approximately 5-minute long burn until SECO, or second engine cutoff, at T plus 8 minutes and 20 seconds. And since we're not releasing our payload today, the vehicle's systems will simulate a signal for payload deployment at T plus 8 minutes and 30 seconds. If we make it to orbit, we would consider this flight to be extremely successful.
And guys,
We
after
are just about 6
so
minutes and 30 seconds to launch, and all of the
okay,
systems are looking good. So we are waiting now for the range to give us the go-ahead for launch, and we'll continue to listen in to the countdown net.
okay, so I guess the range is still an issue, but let's hope that clears up before the liftoff. And guys, after such a long wait, we are
RCO, LC on countdown.
just at the business end of the countdown, T minus 6 minutes and counting. Okay, it's happening now again. Let's keep our hopes high. Let's say that this launch vehicle will be successful and will reach the orbit as intended. T minus 5 minutes and 46 seconds and counting.
RCO, LC on countdown.
This is RCO. Range is
RCO.
green. You are authorized to launch.
Copy.
Yes.
Thank you, sir.
Yes, we are go for the launch, guys. The range is finally green. T minus 5 minutes and counting. The rocket is looking good. The weather is looking
And we're
good.
at 5
The
minutes
range is
to
looking
T0,
good.
and as you've just heard, the range has given us the go-ahead. We are green. And I believe we've got a bit of a crowd gathering here at our headquarters, watching on our big screen here in Alameda. We also have many members of the team watching from home.
There's that big vent. Guys, this is coming to life. T minus 4 minutes and 40
at
seconds.
T minus 60 seconds, the vehicle will transition to its internal control. So we're at 4 minutes and 30 seconds from liftoff. And we will continue to listen to the countdown for these final minutes before liftoff.
Oh god, this is happening. T minus 4 minutes and counting. Venting is going on. Final moments before the launch. I hope the flight software has been loaded and now the rocket is on its own. At T minus 1 minute, the
RCO, LC on countdown. At this time, please verify the range is recording all telemetry.
This is RCO. Range is recording.
Thank you.
cool. So at T minus 60 seconds, you will hear the call out for the switch to internal power, and that means the rocket will be on its own. And
Control room, if you
fingers
require
crossed.
RF data after launch, be prepared to switch over your Grafana pages.
Oh god, okay.
FSO, be prepared to issue option command at T plus 164, calling out at event.
FSO copies.
3 minutes. Reminder, control room, any 3-word hold from here on out is an immediate abort, regardless of source.
Let's hope we don't hear that hold now. Let's hope that. Okay, T minus 2 minutes and 43 seconds. The crowd is gathering, and we could very well expect those cheering and those loud screams in the mission control. Let's hope this rocket is a very successful one, and let's put the show rocket. Astra, let's just put the show.
FTS at this time, please send master enable and watchdog on AFTU.
And work.
Two minutes.
Master
Okay.
Enable and Watchdog have been issued on both AFTUs. Both AFTUs ready to fly.
Copy, thank you.
Under 2 minutes to go till Astra's launch of LV 0006.
Finally, it is happening, guys. T minus 1 minute and 35 seconds and counting. It's happening. Okay, I can't control myself now. finally another
90 seconds.
space provider will be entering into the competition. That would be so great. T minus 1 minute and 18 seconds.
Ace, at this time, start PSD recordings.
Started.
60 seconds. Vehicle
T
is on
minus
internal
1
control.
minute, guys. The vehicle is in internal power. Everything is looking good. The vehicle looks healthy. The range is green. The weather is cooperating. We are just waiting for that countdown to reach 0 and we will
First stage
ignite
lock
this
tank is
rocket.
pressing. First stage fuel tank is pressing. Upper stage tanks have gone to liftoff pressures.
Well, getting ready. T minus 30 seconds. Fingers
30
crossed.
seconds.
Okay, guys, this is happening. Oh my. T minus 20, 19, 18, 17, 16, 15,
15.
14, 13, 12, 11.
10 seconds. Water system on. 8, 7, 6, 5, 4, 3, 2, 1. Ignition. 0.
First motion.
And
First motion.
oh god. Oh god. I guess it was not supposed to do that, but still it's flying. Okay.
Our next objective is Max Q.
Oh man, what just happened? Oh my. But it, whatever the trouble was, it actually recovered from it.
Looks like we're getting some really great footage from our onboard cameras.
This is what is called, what we call robustness. I guess it got stuck on the launch pad, but still it didn't explode. That is the main thing, and it is still flying. Oh god. Wow. Well, let's just see it makes into the orbit properly. Still flying, guys. It's still flying. Recovery to the max. Wow. I didn't expect this to recover at that point of time.
The island.
This was one of the most unique launches that we have ever seen. This is nothing but a contrail. No problem with that.
Approaching nominal downrange trajectory, tracking.
Okay, I guess they are going nominally right now.
And at this point, we should have also passed max Q, which is the period of maximum aerodynamic pressure on the vehicle. This is a significant milestone and the most physical stress the vehicle will experience during launch. Our next milestone is MECO, or main engine cutoff, which is about 30 seconds away.
Guys, it has achieved max Q now. And at that is the thing which actually tests the structural integrity of the rocket, which means it is structurally strong right now. We have the MECO.
Vehicle is passing through max Q.
Okay, not the good. Oh god.
Terminate send.
They have cut the feed.
Terminate received.
That was an eventful launch.
And as you might have seen, there appears to have been an anomaly with the vehicle in flight. And we will first and foremost ensure that our team and others are safe. We take great safety precautions to ensure that no one was put in danger by an event like this. It does look like we got about 2.5 minutes of flight data, which will be incredibly helpful as we make improvements to our next vehicle on our way to reaching orbit. and any flight where we get some data that we can learn from is a successful one in our mind. Although we did not achieve our primary objective today, our team will work hard to determine what happened here. And as we dig into the flight data, we are optimistic about the future and our next attempt.
Exactly. I am so glad that it at least took off from the pad. It was looking so bad after it just ignited off the pad. This was the first time
Let's
they
go
put
ahead
the...
to some quick words from Astra's founder and CEO, Chris Kemp.
Today, after a successful launch and liftoff, Astra's launch vehicle experienced an anomaly in flight. While we regret that we were unable to accomplish all mission objectives for the Space Force, our team captured a tremendous amount of data from the flight. We will work closely with the FAA to complete a mishap investigation. Behind me is LV0007, which will be updated based on what we learned from the flight so we can begin servicing our backlog of over 50 contracted launches. I want to thank our team here at Astra, our partners at the Pacific Spaceport Complex, and I also want to thank our government customers and partners, the Department of Defense, the United States Space Force, the Defense Innovation Unit, FAA, FCC, the Coast Guard, and the community of Kodiak, Alaska. We look forward to seeing you at our next launch.
For now, that is going to conclude our live coverage of the LV0006 mission. I want to give a big thank you to Astra for allowing us to be very transparent about today's test flight, and just a big thank you for today's partnership and bringing live coverage of the mission. A big thank you to you, Carolina, for joining me as well.
Thanks, Thomas. It's not what we were hoping for today, but thanks for having us, and we hope to be back on the pad again soon.
Absolutely. From all of us in NASA Spaceflight, the well wishes to the Astra team, hoping to see them back on the pad soon. For all of you watching, thank you so much for joining us. Stay tuned for more spaceflight news coverage. Until next time, see you then.
Okay. Now this, we have to see the recap, man. We just can't... okay, just a sec. We have to see the recap. We have to see actually what happened. That was pretty unexpected, and this launch was worth it. No matter what you say, but this launch was worth it. And now we shall do the analysis, the failure analysis. Although I wasn't even expecting it to lift off after what just happened just after the ignition. I wasn't expecting it to lift off. It lifted off. It went on till 2 minutes and 50 seconds, and obviously the max Q, it was not able to reach at that point. The max Q, I mean, obviously the max Q is the, you can say, the hardest point of the flight, and if any rocket passes that, you can definitely say that this rocket will be successful in terms of structural integrity. And structural integrity was a big problem because of that thing which we just saw after the liftoff. Okay, let's just see that. And don't worry, guys. You guys at Astra, you guys just rock. No matter what, I mean, the result of it, you must have gotten some great, results and the data out of it, and you will definitely improve. But I must say that whatever be the case, you just put on a great show. Okay.
Fuel tank is pressing.
Let's see it
Upper
again
stage
now.
tanks have gone to liftoff pressures.
What happened
15.
there?
10 seconds, water system on. 8, 7, 6, 5, 4, 3, 2, 1. Ignition, 0.
First motion.
First motion.
We even have this telemetry going on also, right? But it says velocity minus 3 meters per second. Okay. Velocity here, I don't think so. Is it moving at 7 meters per second? We will have to see it again where it actually
Under
got
2
stuck.
minutes.
I'll have to see it again. Did you guys spot the... I guess there is...
Ace at this time. Start
there was
PSD
one,
recordings.
you can say the... What my, the speculation is that there is one... I can see this hold down clamp here, and that didn't release at that point of time which it was supposed to, and that caused the problem. I guess that is the thing which we are seeing here. There are two hold down clamps, one released and one didn't, and that's why we saw that rocket going leftwards or rightwards, whatever you want to say. And mind you that if it was successful also, I mean, if it would pass through the max Q and the second engine would have the second stage would have ignited, I guess they would still again be short of the orbit, because they actually have lost so much of propellant during this lateral translation and recovering the rocket. So let's see, have a close look at
Started.
the hold down clamp.
Seconds. First stage
There was
lock
some
tank.
announcement also just after the launch. There were I mean, let's see first, what did he say? The first,
Tank is
and I'll play it in slow motion this time so that we can have a hang of
10
what
seconds.
happened here.
Water system on. 8, 7, 6, 5, 4, 3, 2, 1. Ignition. 0.
First motion.
First motion. First motion.
Can see
0.
the
First motion.
First motion.
there was some problem with this clamp. We can see something hitting on the rocket itself. There was definitely some problem with the clamp. I guess there this time the issue was not with the rocket, but with the ground supporting equipment.
0.
First motion.
Okay, let me slow it down a bit more. There you can see
Motion.
when it moved on this direction. Can we expect anything else?
First motion.
He said first motion. Maybe I have seen actually the launches of this Astra rocket, and I have seen that it performs that Baumgartner maneuver. But this time, this was the most extreme Baumgartner maneuver, I must say that. The engines are looking fine here. You see, the plumes are looking fine. It is not looking like see guys, if you see, the velocity is negative for some reason, and obviously that is not what we expect. It was 0 initially. I thought this the dash sign is there signifying some just a placeholder kind of a thing, but it was not there when the velocity was 0, and now it says that it is -1. And have a close look at the telemetry also. It actually decreased rather than increasing. It went on to become more negative. The best part was this. The best part was this actually. The little rocket trying its best to come out of the mess it has created. It was like just going out of its way to just disregarding all the mess it has created and going to the flight, going to the space as expired to be. Yeah. We can make that normal. See what happened there. the best part is that the team actually didn't triggered that flight termination system after seeing that thing. They actually waited for the rocket itself to recover. See here, this thing is basically what is done by the flight software here. And people actually, when it comes to rocket science, they tend to go with more of the mechanical aspect of the rocket, and don't go deep inside the brains of the rocket, which is the flight software, which is responsible for correcting its trajectory and everything. And here, whatever you just saw, the thing which actually saved this rocket was its flight software, which corrected itself so that it always remain vertical and does not go outside its leak. So yes, rocket is actually a culmination of everything. So very fascinating to see. And guys, see the velocity. See that? Okay, they have actually
Our
removed
next objective
that
is Max
telemetry.
Q.
They removed the telemetry. It was showing -7 meter per second for some reason. I don't know why. By looking on the onboard cameras, can we figure out something? Well, it does look like the
Looks like
engine
we're getting
plumes.
some really great footage from our
Engine
onboard
plumes
cameras.
are not performing well, because that's not how the engine plumes look like when we have seen how the Falcon launches look like, right? And it's not like the engines are unsymmetrical or something like that. And when the plumes expand, you actually see the plumes does not expand symmetrically. You'll see that in a bit. If they would have crossed a max Q, I would be so surprised, because that was the thing which test the structural integrity of the rocket.
The island.
And during the liftoff, it actually lost the structural integrity. So yeah, was supposed to happen, but yeah, this was totally nominal. The contrail which happens. Okay, now we have the velocity proper, 273 meters per second.
Approaching nominal downrange trajectory, tracking.
Okay, said it's nominal.
And at this point, we should have also passed Max Q.
And
which
we
is
can
the
see
period
actually
of
right now
maximum.
here the rocket is okay. She said at this point we must have passed max Q. The rocket was basically not going in a straight up. It was kind of tumbling, which you can see from the onboard camera. Listen in what she said again.
And at this point, we should have also passed Max Q, which is the period of maximum aerodynamic pressure on the vehicle. This is a significant milestone and the most physical stress the vehicle will experience during launch.
And here you can actually see now the plume starts expanding, and it's so unsymmetrical. The engines are symmetrical, but the plume is so unsymmetrical, which suggests there was some kind of damage to the engines itself, maybe the bell or something like that. But still, it performed till this flight. It's remarkable.
Our next milestone.
And there is something, we can see here, there is some damage here. We can see the damage here. But it is not supposed to happen, I guess.
Main engine cut off,
yeah.
Which is about 30 seconds away.
This plume itself does not look good at all. This is not how the plume expands. And we have she said we should be having the cutoff in about 30 seconds or so, but the cutoff actually happened at t plus 10 seconds or so. And basically it didn't look like it was deprived of fuel, but it looked more like the engine shutdown was triggered by the flight software, if you can see, because after that the rocket just went haywire. Was looking, and then just there you can see the part that was the part which okay, which was actually hanging, and now when it um lost its guidance, we can see it moving. I mean, wow, it was able to manage till this point. That is so remarkable, with a broken first stage. Wow.
Vehicle is passing through max Q.
And now the mission control says that it was passing through max Q, and at that point of time the engine shut down, and we had this thing which we are seeing. And let's see what was happening in the telemetry also. Okay, so let's have a look at the telemetry. It's 730 second meters per 800, it's 62 and 889. Then
Vehicle is passing through max Q.
enemy vehicle is passing through max Q,
Terminate send.
and then the terminates. Whatever.
Terminate receive.
We are still tracking the getting the telemetry down there. The vehicle is still coasting up of the altitude 40 kilometers, 675. Velocity is decreasing, but still we are getting the telemetry. That's me. They have not
And as you might have seen, there appears to have been
terminated till
an
now.
anomaly with the vehicle in flight. And we will first and foremost ensure that our team and others are safe. We take great safety precautions to ensure that no one was put in danger by an event like this.
Still getting the
It does
telemetry.
look like we got about 2.5 minutes of flight data, which will be incredibly helpful as we make improvements to our next vehicle on our way to reaching orbit. And any flight where we get some data that we can learn from is
Okay. The rocket moved from here to here, and we can actually see the damage it created on the ground. I am surprised that nothing caught fire here. I mean, the water is going on, but the water was working in this part, not on this part where the rocket decided to go. So
is a successful one in our mind.
and the clamps look damaged here. So their ground supporting equipments actually did the what should I have the cuts on the rocket. The ground support equipment did not support this time.
And although we
Still getting
Although we
telemetry.
did not achieve our primary objective today, our team will work
Now
hard
it
to
has
determine
stopped.
what happened here. And as we dig into the flight data, we are optimistic about the future and our next. As we dig into the flight data, we are optimistic about the future and our next attempt.
Okay. And that was supposed to happen. They did cut the video, and that was supposed to happen. What do you guys think? I am very much excited about that. The cutoff actually didn't look like it was supposed to happen. It was more like it was a forced shutdown. Let me just see the flight timelines when it was supposed to happen. The cut down, basically the shutdown. Real quickly, up a few. There you go. So main engine cutoff was supposed to happen at 2 minutes 15 seconds. And it was supposed to pass through max Q at 1 minute 15 seconds. So basically the cutoff happened at 2 minute 30 seconds, which was can say intentional now, because obviously it was minute 50 seconds was supposed to happen, didn't happen. Also, I would like to see the time, the timer. Did it stop or what after liftoff? Um, but in normal cases it wouldn't have stopped. So I guess that was the thing. So it 1 minute 15 second it was supposed to pass max. That's why she said that vehicle must have passed through max Q. But since the vehicle was performing, not performing at its best that time, it did a lateral maneuver. So at that point of time, it was not passing through the max Q. When the mission control said that it was passing through the max Q, we just saw what happened at that point of time. Structural integrity, which it was holding at till that point of time, it didn't hold, and just saw what happened. Would like what you guys think. That was actually very awesome that it recovered. I must say that. The best part was that it demonstrated a recovering ability. It failed nonetheless, but it was able to demonstrate that recovering ability, which I don't think so many rockets have. That thing when it oh god, that was totally unexpected launch. I thought it would just we would hear some explosions or things like that, but no. The Astra rocket was full on, in determination to reach the space, that it recovered itself, pulled whatever it had, and finally tried to, you know, climb up to space. But unfortunately, uh, during the max Q, it lost its fight uh, in it for its structural integrity. That's how. Seems like the water deluge system might be drowning the engine. Uh, I don't think so. I suspect there was some problem with the hold down clamps. There was some problem with the hold down clamps. At least they don't have to rebuild the launch pad. They still have to, yeah, total. They don't have to rebuild the total launch pad, but they still have to do some things out there, because we can see okay, let's compare the images of the ground here, because it's okay, we can expect something to go here, but what about this thing, the grass patch right there? How did it look like previously? Let's just go and see. Have a look at this is how it looks like right now. And whoa, that rocket totally destroyed this part of the pad here. I guess this is the cemented part, and this also had can see the craters on the cemented part. We can very well expect some drastic changes in the grassy part, but this cement part also was you can say having some problem. You can see from here. See, everything destroyed. Wow. Whatever you say, this was the best rocket launch for me. And uh, I know the Astra and the people at Astra would be very much devastated by this launch, but I would say, guys, if you are seeing this, keep your hopes high, because you just demonstrated a thing which no rocket has right now. Such a cool recovery after that liftoff is totally mind blowing. And max q is the toughest point at the in the right to the space. Things happen at max q. We have seen so many good rockets explode at max q. So a rocket which was already having some problem with its structural integrity because of its liftoff, we couldn't have expected more, but yes, it did you know demonstrate its recoverability after the liftoff. That was so awesome. I'm not feeling sad or anything like that, because they did some cool thing out there which was totally awesome. But we actually received the telemetry which we can see here till the very till after they cut the footage, obviously, and the mission control uh, they called the flight termination system to be activated, but they didn't activate, I guess, or they activated, maybe the telemetry system was still going on. Don't know that, but yeah, that happened. Okay, what else do we have? What's the price now? Okay, this was the best failure I have seen this year. This was the best failure I have seen in my life. Okay, that definitely was under thrust. Exactly. Started tumbling at 35-kilometer altitude. When it was supposed to pass at max q, the things will, the at the point of max q, the launch vibrations is at the max. Okay, and the vehicle is having its structural integrity tested at that point of time. So max Q is the toughest point in the flight. And the cameraman was expected the high velocity. Yes, no doubt the first motion they called the instead of clear the tower. First motion. Okay, so they meant first motion by this. Okay, cool. Let's see. I bet the ground control crew were under the maximum stress. Yes, they were indeed. Thrust to weight ratio was too low not to stuck a clamp, going from what to happens on KSP if your thrust is too low. Yes, we the all KSP masters out there, we all know what happens when the launch the thrust to weight ratio is not good, and we have seen the clamps interfering because of that. And kind of same thing happened here, and the thrust to weight ratio was not good at this point of time, because it was a kind of expected, you can say, because they stretched, first of all stretched the first stage booster, which has added the weight. And the first time they were adding the payload also this on this flight, so they actually have increased a lot for this booster, this rocket. And yeah, it firstly it used to just climb off from the launch pad, and now it just slowly and steadily raised off from the pad. But having such a slow thrust to weight ratio, and having then also being able to recover, it's such a tremendous, or you can say I don't have any words also right now, such a fantastic feat which they have demonstrated. I am so much happy for them, because when you are having such a low thrust to weight ratio na, then the stability also has a you know a problem, because when the rocket is tipping over and you don't have a bigger big thrust to weight ratio, the rocket just tend to tip over, and we have seen that on the in a KSP also. So okay, feel sorry for the gardener. Okay, it made some altitude but lost thrust or at least pitch control and toppled end over end. Not sure if they popped it with the FTS or not. We actually tend to see the telemetry at the last point of video feed also. So never know whether they terminated or what happened there. Damaged in shipment can get their money back from the FedEx for damages. Maybe. Everyone thought it was going to fall over, but it didn't. I was truly impressed with that feat. I must say that. I wasn't expecting much then. I was just totally impressed by their recovering ability at that point of time. It translates sideways, doesn't go up. That means thrust was equal to the weight. I won't say thrust was equal to the weight at that point of time. I would rather say the thrust means the whatever thrust it was, gaining. It was, thrust was there. It was trying to correct the tipping of the rocket, because when the rocket tips over, the engines have to do the extra work to correct the orientation also. Not only it has to go upright. Now the first of all it has to correct the orientation and then go upright, so it has to do more work. And that's why we felt like it was not going up, but at that point of time engines were doing their best to correct the orientation first of all, and that's why we didn't see it climbing up properly. So yeah, where will it come down? Basically, you can see all over the place that there were only oceans and the sea. So it would definitely go and crash onto the sea only. I think the clamp denied it off the lift off and forced it momentum side, I guess, because we actually saw that some sort of blast which happened during the lift off. Took off, something changed and it lost thrust, and then gimbaled and hovered and translated until it lost weight and could accelerate. Maybe. Someone forgot to tell them that wasn't a hop test. Okay. It didn't explode. That is the main thing which we should be seeing right now. was truly a sight to behold, not as if such failures have never occurred, but the transparency of live streaming, it was courageous, exactly. And the thing is that the same thing we can expect for the Firefly Aerospace also. Let's hope that it does not, because Firefly Aerospace is also live streaming their first ever launch, and no liquid fueled rocket has reached the orbit in its first attempt. So fingers crossed for them. Right 87 continue, great sign. At first motion, see the rocket lockdown fail at base to the right of the booster. Yes, that's what we are saying. The clamps are, you know, right now we are speculating the clamps to be the culprit here. Okay. Then the plume seems like the engines are gimbling to correct some kind of loss of thrust. Uh, if it was gimbling also, then also the plumes are symmetrical only. Okay, the plumes were not symmetrical at that point of time, and when the plumes are not symmetrical, and go you can see the plumes coming. Let me just have that image in front of you so that you can see here you can see this thing. Check. We'll see now. See this thing, this triangle formulation. No, never. You can't have a triangle formulation at all. This simply indicates there was a damage in the nozzle for the first stage of one of the engines or multiple engines. We don't know because of what happened during the liftoff. The plume can't be triangular. The plume has to be circular. No matter if it is gimbaling or whatever it is doing, it has to be circular. Maybe it when it is gimbaling, it will become ellipse. From the way we are seeing from the onboard camera, it may look like ellipse, but not triangle at all, which we can see here.
Away.
So that is a thing. Would have sucked if that had a nuclear bomb on board. Okay, better to get things wrong now and learn from it. Will only make Astra stronger long term. Yep, but they have now have 4 consecutive uh, failures in a row, which is a very hard thing to recover from. I hope they get the courage for this thing. Test flight indeed, no poor reflection on their efforts. If you are not falling, you are not innovating. If you are not failing, you are not innovating enough. Elon Musk. Exactly. I will be switching over to the replay, please. I'll do the replay. I was thinking that doesn't look good. And yeah, I took off and then I thought, I guess I'm an idiot. No, it didn't look good at all. And it was able to recover from that. It just demonstrated its ability to do so. Let's now to the Twitter and see what people are having reaction. Whoa, that was totally unexpected. This thing just came out of nowhere. How very Kerbal, exactly. Exactly. This was so Kerbal. When the rocket just, decides to stick with the launch clamps. This was that only. Wow. Okay. What of, yes, exactly. And there, I think there might be an engine not running. Okay. There's the man's. Hmm. That could explain their poor thrust to weight ratio also. Maybe, or it could be the camera angle. Can't say much, I guess. Could be the camera angle or maybe some engine not working properly. But the plumes which we were seeing again, if the one engine was not working properly, can we get a triangular plume? That is the question. Yes, maybe, but uh, it was not working initially, and then we just saw that that gap was full full. So I guess it started afterwards, maybe, or could just be the camera angle. We don't know. It considering that this might be the consequence of umbilical not detaching damage to the rocket early on. Exactly. Umbilical not detaching. That's what we are uh, speculating right now. The clamps did not work properly. Fast max key. It literally tweeted that. Maybe they tweeted according to the flight sequences which they did before the flight. Obviously, that didn't happen. This one flight sequence was not applicable for this flight, and the mission we should only rely for the just at the point of max q. They when they call out the max, we saw it suffering the unexpected, or you can say the expected in this. So we suffer technical difficulties but achieve 2.5 minutes of flight data. Every launch, whether successful or not, is an opportunity for us. Learn our team will the data and use it. And to iterate on our next one. Best wishes to Astra. Must say this was one of the weirdest launch. Oh. Or is it the engine dying, or is it the one of the clamp exploding? We can't say anything because obviously Tokyo Drift vibes. Got to give the vehicle a lot of credit for getting off the pad with that slide. Mean destroy the strong. Also credit to Astra for the transparency. Yes, exactly. This Joe did it first. Please, Joe did it first. Who was saying Astra did it first? Joe did it first in his attempt. We can see it here. Congrats to Astra on a valiant effort to get to space. To reminded me a lot of this from a few years ago. Joe did it first. Yes, space did it first. Like one of the main engines, kind of, we can actually see there was one blast also, gas. Okay, there was one blast also at the time of ignition, so maybe there was one engine which exploded because of that lateral translation, so we can't say anything. So you can see
2, 1, ignition, 0.
First motion.
First motion.
And there was one. Oh. Okay. So this could also very well happen, guys. We are right now, worrying, speculating that the hold down clamp may have interfered. What if there were initially 5 of the engines running, okay? And then we just saw that explosion there, and one of the engine exploded. And because of that, it lost the thrust at that point and it tipped over. It could very well happen because of that also, and that could explain the thrust to weight ratio also. So there are two possibilities right now. The clamp had some problem, or the blast which we saw was of the engine, and it just totally lost the thrust. Because of that, the rocket tipped over, and
first motion. 3,
look here carefully. You will see the blast, and then just after, first of all, what happened, it blasted off the pad, lifted off the pad, and then that blast happened, and then it tipped over. So I think there was an engine issue.
1, ignition, 0.
First motion.
First
Blast,
motion.
and then lost the thrust at that engine, and then tried to recover it. I don't think so. It got to Miko. And obviously man is there. That disconnect doesn't look like. See, there are two possibilities which actually have happened. We don't know. This disconnect didn't look like, or there was a problem with one of the engines. Maybe this disconnect which didn't look like, and it just uh, slammed on the rocket, had maybe it damaged that part which was sticking out during its flight. They're just relations and everything. And there's the starship is going on. Okay, so it looked like it was obviously underperforming at the velocity for a long time to reach max q. Was underperforming the whole way up, for the engines cut off and the vehicle spun out of control. uh okay. What is it? What does he But now I am off for a swim like the rocket. Okay, we'll see. Does Obviously he'll make a video in which we'll get to know proper analysis of it. But right now there are two problems which we can see. Maybe it can be the combination of both of them, or one of them doing the job. We can see this thing again and again and again and again and again. Lifted for about 500 meters, always close to the ground. Yeah. They have already contracted from Defense Department for like 50 plus launches. Yes, they have contracted, and that's why they were able to, not go bankrupt before this launch. We'll have to see how things will go. Two breaks at plus two. Yes, we can see that. Yes, this is like their fourth failed attempt. Everything was thrown out by correction. It was on its knees at one point. At least it left the pad, and you learn from your mistakes. That is the main takeaway which I'm taking from this flight. I don't care what happened just after the liftoff, but what happened, after it tipped over is what matters to me. You think they had some control or idea of where it? I was thinking else to do a fun video, something with Thomas. That looked like part of the rocket that folded up at start, not clamp. It again. Don't think so though. There is nothing folded up on the rocket. Okay, whatever this is the hold down clamp which we can see, and yeah, that's basically it is. uh,
10 seconds. Water system on. 8, 7, 6, 5, 4, 3, 2, 1. Ignition.
Went in on to full thrust.
0. First motion.
And there you go. Yes, there was a problem with the clamp. We can actually clearly see when it, goes in this slow motion kind of a thing. There, when it was, released the clamp, there was something which actually hit the rocket.
Ignition. 0. First motion.
There
First
you
motion. First motion.
very hard to say from this footage. Sometimes it looks like there was a clear umbilical problem. Sometimes it looks like there was an engine problem. We can't actually maybe the umbilical, that thing which actually went on to hit the rocket, that happened because there was an explosion in the engine. Can't say anything. We can't say anything. Can't. But we can definitely see the blank space here, which could mean that they lost one engine. But then this happens.
Eight, 6, 4, first motion.
There are all explosions going on, and maybe that could be of the ground support equipment. But if, I guess, I mean, blank space which we were seeing was of the because of the camera angle. I don't think so. That could indicate the engine problem, because I don't know. I guess that's my speculation. The blank space which we were seeing was because of the camera angle and not because they lost an engine or whatever. But obviously the engines had some issue which were evident from the plume effect, which I already told you. Maybe there should be more space on exhaust. We'll have, I guess, more clear answers are there with the Astra only. I don't think so there is a problem with the exhaust, because previously it had lifted off from the pad, so there was no as such problem with the exhaust out. Almost looked like the ignition was a tad early. Sync problem, I don't think so. Maybe there could be a sync problem also, but I don't the sync problem could happen when one of the clamp decided to not release the rocket at that point of time when the other clamp released. That could only be the sync problem which I could think of, because if the thrust also comes to its full power, then also the clamps have those ability to hold the rocket at its place. So if there is a sync problem, the sync was between the clamps. That was inside the rocket. Little explosion just after they saw the first movement at the base, you can see. the flap of metal fly up and back down into the place. Okay. So you are saying that it was a part of the rocket.
Zero. First motion. First motion.
No, it came back, but was it there with the rocket or not? That is the thing which we can't. Oh yeah, it is actually moving. If you can see here, that thing is actually moving. Yes, it was kind of a part of the rocket only. And but that could happen. One of the clamp did not release at uh, that point of time which it was supposed to release. Therefore that created that damage to the structure, and it damaged the rocket. We can see it clamp. We can see it here. I was able to see. Yeah, so that was a part of the rocket, but again we can't conclude anything right now. Could be a engine problem, could be umbilical problem. The engine blew, the thing hitting the side of the rocket was that down the pipe folding back up. Yes, there was, that's what I am saying. There could be an engine and there could be a umbilical problem, or could be both. And right now the things look like that was both. And maybe if the engine blew, then that could explain the tipping over. And if the engine blew, but again the clamp did not perform well and it was still holding, and that could also explain the tipping problems. And in Miko, I think that rip in structure was exactly where it damaged on the land. Exactly. Yeah, you are right. I also think that way. No, I don't think so. Engine blowing up would do much damage, because I guess they would have isolated the engines, just like what SpaceX has done with their Merlin engines. If any of the engines explode, it does not affect other engines. So maybe they have gone with that also. Flight 2. The rocket plowed the field. See, such a huge crater it created. This is the image. Such a huge crater, no creator, it's crater. The huge crater it created, which you can see here. It was such a flat surface, and then now, wow. Okay. So I guess, guys, I can end the stream now. It's been, wow, 5 a.m. right now here. I should go sleep now. This was a long day for me. So guys, if you like what I do, you can, subscribe to my channel, hit that like button. And if you want to support me, you can do so by becoming a Patreon. Link is down in the description, or by becoming a member of this channel. It really, really helps the channel. And you can always do the one-time funding. Super chats always enabled for that. Uh, there is a telemetry. I would like to know altitude and heading. There is a telemetry, yes, and it was negative at first. Then it, we began. Uh, then it went on to become positive, and then finally, after the termination the command was sent, then also the telemetry was being received. Yeah, Adrian, I hope, thank you so much for your appreciation. I am glad that you like the stream. So thank you so all for it was an amazing experience in Astra. Don't worry, we are all with you. You will come back stronger, we all know, and you did put on some spectacular show for all of us, and you did demonstrate that ability to recover from such a catastrophe after liftoff, which I don't think any rocket has right now. So kudos to you, and hopefully the next flight would be the flight when we will see a rocket going to the space, finally to the orbit successfully. Okay, 5 a.m. Wow, now I can feel my body responding to that. Okay, so guys, thank you all for coming in, and until then, this is Priyanshu Royla. You just saw Rocket Gyan. Stay safe, stay healthy, and